Azure Data Studio is a modern, cross-platform management front end for interfacing with one of the most popular relational database platforms on the market, SQL Server. It's easy to deploy and use, and it's opening the doors so that everyone can better leverage databases in their everyday work. Hi, I'm Adam Wilbert, and I'm excited to introduce you to Azure Data Studio. I've been working with the program since it first appeared in public preview several years ago, and I use it to manage my SQL Server and Azure SQL databases across all of my Mac, Linux, and Windows PCs. In my LinkedIn Learning course, I'll show you how to connect to a database server, create data tables and edit data with the robust code editor, and I'll show you how to extend Azure Data Studio's capabilities to fit your unique requirements. This is a fantastic program, and I'm glad to have you along for the journey. So let's get started. This course focuses on using Azure Data Studio, but in order to do so, we need to build on top of a foundation of relational databases. Because of this, you'll need to have a little exposure to SQL databases in order to get the most out of this course. I expect that you'll have an understanding of what a database server is and what it does, and also an awareness of the basics of the SQL language. You don't have to be a query writing wizard, but if you can identify the basic components of a select query, then you'll be fine to proceed here. If you feel like you need a short introduction or a quick refresher on the basics of SQL Server, take a look at my course Learning SQL Server 2019, and then you'll have everything that you need to be successful here in Azure Data Studio Essential Training. Installing Azure Data Studio on Windows is pretty straightforward. Before we begin though, it may actually be the case that you already have Azure Data Studio installed and not even realize it. Since October 2020, Azure Data Studio has been installed automatically on Windows if you installed SQL Server Management Studio version 18.7 or later. So if you work with SQL Server databases regularly and have SSMS installed, check your computer to see if you already have Azure Data Studio. If so, you're already done and can move on to the next chapter of this course. For everyone else on Windows that doesn't have it yet, you can find the standalone installer at this URL. Simply scroll down on this page a little bit until you get to the Download Azure Data Studio section. Here, next to the Platform for Windows, we'll see we have several different files. I'll choose to use the User Installer file. Just click on that and it'll download to my system. Once it's done, we can use that file from the Downloads folder to start the installation. First, we need to accept the user agreement. Then I'll just choose the default file location there, and we'll create the program shortcut group. I'll also choose the option to create a desktop icon and to register Azure Data Studio as an editor for supported file types. With all three of these checkboxes ticked, I'll press the Next button. I can review the installation steps and press Install. When it's done, I'll have the new Azure Data Studio desktop icon right here, and I can leave the option to Launch Azure Data Studio checked and press Finish. That'll launch the program, and we'll see a couple of warning messages over here on the right. This first one says that preview features enhance your experience in Azure Data Studio and asks if you want to enable them. I suggest pressing the Yes button here. You can also make that change to enable those preview features by going over to the Settings button over here on the bottom left-hand corner, this gear icon, then going up to Settings, then doing a search for Preview Features. This will bring you to the checkbox to enable the preview features if you need to turn that on or off later on. For this course though, I recommend leaving this on. Let's go ahead and close the Settings tab, and that'll take us back to the Welcome tab. Now at this point, Azure Data Studio is up and running on our Windows computer. Installing Azure Data Studio on Windows is pretty straightforward. Before we begin though, it may actually be the case that you already have Azure Data Studio installed and not even realize it. Since October 2020, Azure Data Studio has been installed automatically on Windows if you installed SQL Server Management Studio version 18.7 or later. So if you work with SQL Server databases regularly and have SSMS installed, check your computer to see if you already have Azure Data Studio. If so, you're already done and can move on to the next chapter of this course. For everyone else on Windows that doesn't have it yet, you can find the standalone installer at this URL. Simply scroll down on this page a little bit until you get to the Download Azure Data Studio section. Here, next to the platform for Windows, we'll see we have several different files. I'll choose to use the user installer file. Just click on that and it'll download to my system. Once it's done, we can use that file from the Downloads folder to start the installation. First, we need to accept the user agreement. Then I'll just choose the default file location there, and we'll create the program shortcut group. I'll also choose the option to create a desktop icon and to register Azure Data Studio as an editor for supported file types. With all three of these checkboxes ticked, I'll press the Next button. I can review the installation steps and press Install. When it's done, I'll have the new Azure Data Studio desktop icon right here, and I can leave the option to launch Azure Data Studio checked and press Finish. That'll launch the program, and we'll see a couple of warning messages over here on the right. This first one says that preview features enhance your experience in Azure Data Studio and asks if you want to enable them. I suggest pressing the Yes button here. You can also make that change to enable those preview features by going over to the Settings button over here on the bottom left-hand corner with this gear icon, then going up to Settings, then doing a search for Preview Features. This will bring you to the checkbox to enable the preview features if you need to turn that on or off later on. For this course, though, I recommend leaving this on. Let's go ahead and close the Settings tab, and that'll take us back to the Welcome tab. Now at this point, Azure Data Studio is up and running on our Windows computer. Installing Azure Data Studio on macOS is even easier than it is on Windows. We'll start at the same URL and scroll down until we get to the Download section. For macOS, we'll see that we only have a single file that we can download, and it's packaged as a zip. So go ahead and download that file. Then we'll go into the Downloads folder and find it. Let's double-click on it to extract the zip file. And inside of there, you'll see that we only have a single application file. Simply drag and drop that into your Applications folder. Then you can go into that folder and double-click on it to start it up. macOS is going to warn me about the file that was just recently downloaded. I do want to open it, so I'll press the Open button, and it should start up. Now, the first time you start up Azure Data Studio, you might get a couple of warning messages over here on the far right-hand side. The only other thing that we need to do in order to get started is to enable some preview features. To do that, we'll go over to the gear icon on the bottom left-hand corner, click it, and then choose Settings. In the Search Settings box up at the very top, I'll do a search for Preview Features, and I want to make sure that I place a check mark in this box right there. That'll set it up so that your system is working exactly the same as my system throughout the rest of the course. And that's all there is to it. We can go ahead and close the settings file there, and that'll take us back to the welcome screen. And now we're set up with Azure Data Studio on macOS. The process for installing Azure Data Studio on Linux machines will vary slightly depending on the particular flavor of Linux that you're running. I'm currently on an Ubuntu machine, version 20.04.2 to be specific, but you can also install it on computers running Red Hat or Debian. Just like with the macOS and Windows installations, we're going to start at the Microsoft documentation page for Azure Data Studio. Then we'll scroll down until we get to the Download section, and we'll see that for Linux, there's 3 different files that we could work with. The .deb file will be used if you're on Debian Linux, the .rpm file if you're on Red Hat, and the .tar.gz file is used for Ubuntu. I'll go ahead and click on the tar.gz file and save it into my Downloads folder. Then, before we leave this documentation, I want to scroll down just a little bit farther and take a look at the specific instructions for Linux. Here, it lists out the specific commands you'll need to run depending on the version of Linux that you're working with. So here we have Debian Linux and the bash commands that you want to send to your installation. Then below that, we have some information about missing dependencies that you want to pay attention to. Below that, we have the similar instructions for Red Hat Linux, including the bash commands, as well as some dependency information. And then finally, we have the same information for Ubuntu that I need to pay attention to. Here at the top, we have the bash commands to install everything. And then down below, we have the information about potential missing dependencies. So I want to make sure that I have all of these dependencies installed on my machine in order to successfully run Azure Data Studio. Let me scroll back up here a little bit and I'll find the bash command to install everything. Now the first couple of commands here are just going to simply extract the files from the tar.gz archive. I'm going to do this in a slightly different way so I can skip these two lines. But I am going to copy the lines that say echo and source. Let me go ahead and just copy all of that, and I'll save it on my clipboard for just a moment. Now we can go into the Downloads folder, and we'll find the archive file that we just downloaded. I'll go ahead and double-click on it. That'll start up the Archive Manager. Next, I'll press the Extract button in the upper left-hand corner. Then I want to extract everything into my Home folder, and I'll make sure that I have the options set to extract all of the files, as well as to keep the directory structure. With both of those options enabled, I'll press the Extract button in the upper right. Once the extraction process is complete, we can go ahead and close the window and close the Archive Manager. Then if I switch back to my Home folder, we'll see the new file folder right there with all of the application files inside of it. Now let's take care of those dependencies. For that, we'll open up the terminal. The first one that I need to install is called libxss1. We do that with sudo apt-get install libxss1. When I press enter, it asks me for my password, so I'll go ahead and type that in. And it'll go through and check to see if I have that software. Now it looks like I already have the newest version installed, so nothing needs to be changed. All right, let's take a look at the second dependency. This one is sudo apt-get install libgconf-2-4. Now it looks like I don't have this one, so I do need to install it. I'll press Y and press enter, and it'll download the required files. All right, that one's done. The final one is called libunwind8. So I'll send the command sudo apt-get install libunwind8. When I press enter, it does its check, and it looks like I currently have the newest version, so once again, nothing needs to be installed. All right, so that takes care of my 3 dependencies. The final thing I need to do is paste in those 2 lines of text that I copied from the documentation. This will export the path to the executable file and store it in my bash rc file. I'll press enter, and both of those lines get entered. Then all I need to do in order to run Azure Data Studio is send the command Azure Data Studio. This is all one word. When we press enter, it'll launch Azure Data Studio in a brand new window. The first time you run it, you might get this authentication required message, and once again, I'll just type in my user password. Finally, we need to enable the preview features. For that, we'll go down to the gear icon in the bottom left-hand corner and choose Settings. Then in the search box, I'll search for Preview Features. And finally, we'll check this box here to enable unreleased preview features. That'll set up your computer to work just like mine throughout the rest of this course. You can also go ahead and dismiss this pop-up window over here on the right. So with this option enabled, we'll go ahead and close the settings, and that'll take us right back to the welcome screen. So now Azure Data Studio is up and running on Ubuntu Linux. Azure Data Studio is a management front end for working with SQL database servers. Because of that, Azure Data Studio really doesn't do anything until you first connect it to an existing database server. It can't create databases or store data all by itself. So in order to move forward with the course, we'll need something to connect to. If you already have access to a database server, then you're almost ready to move on. You simply need to gather a few pieces of information from your current setup. First, you'll need to know the IP address or the network name of the machine that you want to connect to. If your database server software is running on the same computer that you're currently using, then you can make a reference to localhost instead of using the IP address. You'll also need to know the server's listening port. For SQL Server databases, the default port is 1433, PostgreSQL uses 5432, and Oracle database servers typically use port 1521. However, these are all user configurable and may be different for your server, so you may need to verify with an administrator. Finally, you'll need to know the login name and password for an authorized user account. For this course, it would be preferable if you have an account with administrator privileges so that you don't run into permission errors as we move through some of these examples. Now at this point, you may be wondering about Windows authentication instead of SQL Server or username and password authentication. Windows authentication is a way of logging into a SQL Server instance using the credentials of the operating system's currently logged in user, so you don't even need to supply a username and password to gain access. Azure Data Studio does support Windows authentication, and if you're running Azure Data Studio on a Windows PC, and your SQL Server instance is also running on a Windows machine, then you can easily use the Windows authentication mode to log into the server. If you're running Azure Data Studio on a Mac or a Linux computer, or your SQL Server is running on Linux or in a Docker container, and in my case both of these conditions are true, then Windows authentication becomes a little bit more challenging to implement. It's possible, but you'll need to join your OS to an Active Directory domain controller and authorize user credentials through something called Kerberos. This requires manually modifying configuration files and is simply beyond the scope of this course. For more information on how to set this up, I'll refer you to the documentation page at this URL. For this reason, I'm going to stick with the standard username and password authentication for this course. Now, if you don't yet have access to a SQL database server instance, or if you want to configure your own server for this course so that you can freely play around without potentially messing up a live production server, you have a couple of options. If you're running a Windows machine, Microsoft provides a developer edition of SQL Server that's free to use for educational purposes. You can download and install that on your local computer or a computer on your network. You can find installation instructions in my course, Learning SQL Server 2019. Take a look at the movie in Chapter 1 called Install SQL Server, and in Chapter 2, watch Log into the Server to see how to set up the system administrator or the SA account. Another option is to install SQL Server on a Linux computer or in a Docker container. For instructions on this route, take a look at my course, SQL Server 2017, Linux, Docker, and Mac OS. I personally find the Docker option to be the easiest for quickly setting up a SQL Server instance for training purposes, so this is the method that I'm going to use. If you want to replicate my setup exactly, I'll demonstrate those steps in the next movie. Once you're set up with a SQL Server instance either on Windows, Linux, or Docker, you'll need the IP address, port, and login credentials in order to connect to Azure Data Studio. So gather those details and write them down. There is one other alternative at our disposal, and that's to connect to Azure Data Studio to a database in Microsoft's Azure Cloud platform. To create an Azure SQL database, you can follow along with the movie in Chapter 1 of SQL Server 2016, Provision a Database. The connection process is a little bit different than it is with a traditional SQL Server instance, and I'll cover those steps in an upcoming movie. So don't worry about finding the IP address and login information if you choose this cloud-hosted option for your database server. For this course, it really doesn't matter what type of database server you'll be connecting to, and there's lots of different options and configurations that will work depending on your situation and the hardware that you have available. In the interest of full transparency, though, I thought it might be helpful to run through the process that I'm using to get set up and running with a SQL Server instance that I can then connect to in order to explore how Azure Data Studio works. I'll be working on a PC, but the process will be similar on a Mac or a Linux computer, and it all starts with installing Docker. You can start at docker.com, then point to Products, and underneath Features, click on Docker Desktop. This will allow us to download the installer file for the Docker Desktop application for your particular operating system. I'm working on a Windows PC, so I'll click on the Windows link, and that'll download that file. Once that's done, we can close the web browser, and we'll go through the installation process. I'll find it inside of my Downloads folder, and there is the Docker Desktop installer. I'll double-click on it to get it started. I'll allow Windows to make changes to my computer. Then on this screen, I'll make sure that both of these check marks are put in. I want to use the Windows subsystem for Linux version 2 instead of Hyper-V, and I'll also add the shortcut to my desktop. With both of those selected, I'll say OK, and it'll download and unpack all of the files. When it's done, you might be prompted to restart your computer, in which case that would be a good idea to do that. I'm not prompted though, I'll just press the close button, and we're done installing Docker. Now I'll just double-click on the desktop icon to start it up. The first time I do, I'm prompted to accept the terms of the licensing agreement, so I'll do that there. The first time you launch Docker on Windows, you'll see this message here telling you that the WSL2 installation is incomplete. There's one additional component that we need to install, but this one comes from Microsoft. Go ahead and click on the hyperlink right there. That'll open up your web browser in the background. I'm just going to drag this window to the bottom of my screen to get it out of the way. Now, the only thing we need to do here is step number 4 is to download this package and install it. So I'll click on this link for the WSL2 Linux kernel update package for x64 machines. That'll download one more file to my Downloads folder, and we can once again close the web browser. I'm going to minimize Docker here and go back out into my Downloads folder. There is the WSL update file. Just double click on that one to run it. I'll say next to this screen. I'll allow it to make changes to my computer, and that'll install the files. That one goes pretty quick, and we're already done. All right, we'll go back up to this little dialog window there, and I'll press Restart. That'll restart the Docker Desktop application. And at this point, we're ready to go. I'm going to press Skip Tutorial, and that'll take us back to the main page for Docker. So now that Docker is running, we can set up our SQL Server container. And for this, we'll need to use a command line tool, like PowerShell here on Windows, or the terminal application if you're on Mac OS or Linux. The specific commands that you'll need I have written out already in the Chapter 2 exercise file named docker SQL server.txt. So let's take a look at that. Now there's different commands depending on whether you're on Windows, Mac OS and Linux, or if you're on an Apple Silicon Mac. So grab whatever command is useful for your specific installation. I'm going to grab this one here for Windows, and I'll copy that to my clipboard. Then I'll open up the PowerShell application, and once again you'll use terminal if you're on Mac OS or Linux. And I'll paste in that text. When I press enter, the computer is going to check to see if the image is found locally on your computer, and if it's not, it'll download the image and create a new container. When it's done, we'll have our SQL Server container up and running. So let's take a closer look at the command that we just ran. It starts with the text docker run. We then accept the end user licensing agreement, and then we supply a password for the system administrator or the SA account. The strong password that I'm using is just Adam123456. You can change this password to anything that you'd like. Just make sure that you include capital letters, lowercase letters, and numbers, and have more than 8 characters. Next up, we're forwarding some ports. I like using port 1401 for this, and we'll map that to port 1433. What's happening here is that we'll send requests to Docker on port 1401. Docker will then turn around and forward our request inside of the container to port 1433, which is what SQL Server listens on. You can choose another port to forward to instead of 1401 if you have a reason to. It doesn't really matter. But the listening port, this second number, should always be 1433. You can also elect to use the same ports on both sides of the container by typing in 1433:1433, so you can just send communications straight through. I like forwarding a different port number here so that I have the option of running multiple Docker containers, each with their own SQL Server instance inside. Next up, we have the --name command, followed by the name of the server. In my case, I'm naming it SQL Server, but it's wrapped onto the next line here. So it's SQL, SERVE, and then the R is way over there. So the name of my database container is simply SQL Server. Finally, we have -D, followed by the path to the image provided by Microsoft for the SQL Server instance that we're running. In this case, we're running the 2019 latest version of SQL Server. This one will already have all of the security patches and bug fixes already applied to it. So now that our container is running, we can issue the command docker ps, and that'll show me a list of all of my running containers. You should see a name here that says that the SQL Server container has a status of up. This means that it's currently running. If for whatever reason you're not seeing the running container here, you can type docker ps-a. This will show you a list of all of your containers, whether they're running or not. And if you find it here with a status of exited, it means that the server didn't get started correctly. You can remove it with the docker command docker rm SQL Server, then try creating it again and make sure that you've typed in everything exactly as I did from the exercise file. Other useful Docker commands are docker stop SQL Server and docker start SQL Server to stop and restart the container if you need to. And that's it. We now have a Docker container that has SQL Server running inside of it, and we can connect to it with Azure Data Studio. For the connection details, since this is running on my computer, the machine name will be localhost. The port that we set up is 1401. The username will be the system administrator or SA account, and the password that I set up for my container is Adam123456. So now I have everything that I need in order to establish a connection between my SQL Server instance here in Docker and Azure Data Studio. Once you have Azure Data Studio installed and have gathered the connection information about your database server, you're finally ready to log in. The process is exactly the same, regardless if you're working on Windows, Linux, or Mac OS. When you first start Azure Data Studio, you'll see this main Welcome tab. It has several options at the top to help get you started. You can create a new database connection, write a database query, create a new notebook file, or even deploy a server using scripts that are built into Azure Data Studio. These same four options are also available by going to the New button here at the top, and you'll see them all listed out right there. Below that on the Welcome screen, if I scroll down, you'll find some official links to some documentation and videos. And below that, we have some information about popular extensions that can be added into your application. So the Welcome tab has lots of useful information and resources. If you scroll back up to the top and then close the tab, you can always get back to it by going to the Help menu and clicking Welcome. And that'll bring you right back to that Welcome tab. So the first thing that we need to do is create a connection to the SQL Server database server that I set up in the prior movie. We can either click the Create a Connection button here on the Welcome tab, or we can go over to the sidebar, which is called the Activity bar, and click the top icon at the very top to open up the Connections panel. This panel will eventually show you all of your database connections, but there's a button here at the top that says Add Connection if you don't have any connections, as well as this additional button here at the top that has a little server icon with a plus. Any of these options will do basically the same thing. It'll open up the new connection panel over on the right. This is where we'll put in the connection details to our SQL Server instance. At the top, we have two tabs, one for recent connections and one to browse saved connections. These will allow you to easily reconnect to servers that you've accessed previously. I'm going to switch back it over to recent. Below that are all of the various fields that we'll need to populate in order to connect to our SQL Server instance running in Docker. The connection type will be Microsoft SQL Server, and in fact, that's actually the only option that we have at this point. For the server, type in the IP address of your server that you've gathered previously. If you're running Azure Data Studio on the same machine that's also running SQL Server on Docker, like I am, you can type localhost here instead. For the authentication type, we have the option of either SQL login, Windows authentication, and Azure Active Directory logins. Notice if you choose Windows Authentication or Azure Active Directory that it doesn't prompt you for a username or password. Let's make sure we switch this over to SQL Login, and we'll get the two fields for username and password. I'm using the system administrator name for the SQL Server login, so that is SA for SQL Server. Then the password is the one that we established when I created the Docker container. And if you remember, I used Adam123456. You might have changed the password in the setup, so just make sure you type in whatever you used. I'll choose the option here to remember the password so I don't need to type it in again if we reconnect to the same server. There are additional options to connect to a specific database instead of all of the databases on the server. You can also display the connection in a group over on the left server sidebar. We'll talk about groups in an upcoming movie. Finally, you can give this connection a name so that it's easier to recognize later. I'll leave mine blank for now, but we'll come back here in just a moment. Now, before we press connect, there's one additional option that we need to enable, so I need to scroll down here and click the advanced button. This will give you a long scrolling list of additional connection parameters that you may need to set depending on the particulars of your setup. I'm going to leave most of the defaults or leave them blank here, but I do need to scroll down until I get to the general section where I'll find the option for port. Remember that we used a custom port for the Docker container, and I used port 1401, so I'll fill that in there. Okay, with that little detail filled in, I'll press the OK button at the very bottom. That'll take me back to the main connection details page, where I can finally press the blue Connect button. If everything was filled in correctly, you should now see the connection appear in the Connections window over on the left. It'll also open up the server dashboard in the main portion of the screen. You'll see we get a new tab for that. The server dashboard gives us a good overview of the database server that we've just connected to. We can see that it's running SQL Server version 15.0.4223. It has a computer name of this name right there. We're running the developer edition of SQL Server on a 64-bit machine, and it's running on Ubuntu Linux. Remember that all of these details are coming from the Docker container. On the left, we have the reference to the server that we just connected to. It shows the IP address, or the name of the machine, in our case localhost, the port that we're connected to, the database that we're connected to, and since I didn't specify one, it's just saying default. And then finally, we have the username that we connected as, in my case, SA. Underneath that, we have folders that represent all of the different objects on the database server, so I can expand databases, and inside of there, we have system databases, and here are the 4 system databases for SQL Server. So this is where you'll begin to browse the contents of your database server. Now, this name that we have here at the very top isn't very clear because it just lists out all of those details. We can clean this up in our display by naming this connection. To do that, I'll press the Add New Connection button here at the very top, and that'll reopen the Connections window on the right. Then I'll select my previous connection from the recent list, and it'll fill in the majority of the details. Next, I'll come down to the very option where we have the name parameter. This time I'll give the connection a name. I'll call it SQL Server on Docker. Then I'm just going to go over to the Advanced tab just to make sure that the port is still set. I'm going to scroll down here and I'll see that it actually is not. So I'm going to type that in again, 1401. I'll press OK, and I'll press Connect again. That'll create a second connection to the same database server, and I have it listed right here. Notice though that when you hover your mouse over it, it still gives you those connection details. It says we're connected to localhost, port 1401, the default database, and the SA user account. At this point, we can also remove the first connection that we made. Simply right-click on it and choose Delete Connection. So now I have a single representation of that connection, but we're still connected to the exact same database server. I can also go ahead and close all of these tabs over here on the right. So that's how you establish a connection between Azure Data Studio and your first SQL Server instance. The same procedure works regardless if your server is running in Docker, like mine, or on a standalone Linux or Windows PC. Azure Data Studio has the ability to work with additional relational database platforms beyond SQL Server. This option is enabled through the extension marketplace. Let's quickly set up a brand new database server based on the PostgreSQL platform using Docker, and then we can connect to it from Azure Data Studio. In the Chapter 2 folder of the exercise files, you'll find a file called docker postgresql.txt. It has the command that we need to run in order to set up that PostgreSQL container. I'm simply going to highlight it right here and copy it to my clipboard. There's also a note in this file about a potential error that you might find if you're working on Windows. If you see the error OSS DB tool service component exited unexpectedly when we install the PostgreSQL extension in a few minutes, then you may need to install an additional component, the Visual C++ 2015 redistributable. I have a link right here for the file in case you need it. But this is only if you see that error on Windows. Okay, let's go ahead and install the PostgreSQL extension on our Docker container. I've got this command copied to my clipboard, so I can go ahead and close this text file and start up the PowerShell window. Remember, if you're using macOS or Linux, then you'll be using the terminal application. The Docker command is docker run --name followed by the name of the container that we're going to create. In my case, I'm simply calling it PostgreSQL. Then, just like with SQL Server, we're going to forward some ports. PostgreSQL uses port 5432 by default, but I'm going to use port 5401 to communicate through the Docker container. Next, we're setting up the password for the Postgres user account, and I'm going to use my favorite super secure password, Adam123456. Finally, we need to specify the image that we're going to use to create that container, and we're using the Postgres latest image. So with all of this put in, I'll just press enter, and it'll start the process. Now the first step is going to look and see if it can find that image on my computer, which it does not find, so it needs to download it before it can install. Once that's done, our PostgreSQL server should be up and running. Let me go ahead and close out of the PowerShell window, and we'll take a quick look at Docker Desktop. On the Containers page, you should see a list of your existing containers that you've set up in Docker. Here is the one that we've set up previously for SQL Server, and here is the one that we've set up for PostgreSQL. I can see that both of them have a status of running. There's some buttons over on the far right if you need to start, stop, pause, or restart your server, as well as to just delete it when you're done. Anytime you reboot your computer, you'll need to come back into Docker Desktop and restart each of these servers so that they'll accept connections. Both of mine are running, so that's great. Let's go ahead and close Docker Desktop, and we can go back into Azure Data Studio. Now we need to visit the extension marketplace to enable the feature. You'll find it using this icon here in the activity bar. The icon with the couple of squares will open up the extensions marketplace, or we can do a search for PostgreSQL. That'll find the PostgreSQL connection extension published by Microsoft. You can click on it to get some additional details about it, and then press the install button here at the top. That'll take just a moment to download the file and install it. When it says installed, you're ready to go. Now this is the point where you would see that error message on Windows about the OSS DB tool service. So if you're seeing it at this moment, it'll be a little pop-up window over here in the bottom right-hand corner. That's when you need to know that you go back to that exercise file and download that additional component. But I'm not getting that error now, so I'm going to go over here into my server connections panel and open that up. Then we can create a new connection. I'll press the Add New Connection button here at the top. That'll open up the connections panel on the right that we've seen previously. Then we'll just fill in the details. For the connection type, I'll use the drop-down menu, and we now have a new option for PostgreSQL. The server name is our localhost. The authentication type will be password. The default username for PostgreSQL is simply Postgres. And the password that I used was Adam123456. I'll choose the option to remember the password, and we'll give the connection a name. I'll call this PostgreSQL on Docker. Finally, I need to come down and press the Advanced button, where I can fill in the customized port that I used, 5401. I'll press OK. That takes me back to the main page, and I'll press Connect. That'll make a connection to the PostgreSQL server that's running in Docker, and just like with our SQL Server database server, we can expand the Databases folder to see the database that's inside of it. In this case, we just have the default Postgres database. So that's how you can connect to PostgreSQL database servers using Azure Data Studio. You'll simply need to enable the extension in the marketplace first. I'll also point out that there's an additional extension for Oracle databases if you need to connect to systems using that platform as well. Besides the traditional on-premises installations of your database servers, Azure Data Studio can also connect to your Azure SQL databases that are hosted on Microsoft's cloud platform. Let's take a look at the portal.azure.com website and get started there. I've logged into my Azure portal, and from here I'll click on the menu button in the upper left-hand corner and then come down to SQL databases. Now I've already gone ahead and deployed an Azure SQL database that we can connect to, and mine is right here called My Azure SQL DB. If you need to create a new database, you just click the plus create button right over here, and that'll start up the process of moving through and creating those resources. You'll need to deploy a new resource group, a server, as well as the database itself. But once that's done though, you can go back into your SQL databases portion of the dashboard and take a look at the database that you just deployed. When you click it, it'll take you to the overview page. Here, it'll reveal the name of the server that the database is on. In my case, my server name is kineticoserver.database.windows.net. We're going to need this piece of information to log into it from Azure Data Studio. So hover over it here, and you'll reveal a little icon that'll copy it to your clipboard. Now we can go back into Azure Data Studio. From here, the process is similar to what we've seen already. In the connection sidebar, you'll come up and click on the New Connection button. Then our connection type will be Microsoft SQL Server. For the server, I'll paste in the text that I just copied to the clipboard. That'll be the reference to the Azure server. The authentication type, we'll switch over to SQL Login, and then we need to supply a username and password. Both of these were created when I deployed the database on Azure. Let me go back and check real quick so we can verify what the username is. Back in the Azure portal, on the overview page for my database, I'll find the resource group section and click on the resource group that I created called Azure RG. Then inside of the resource group, we'll find the server that the database is on. Mine is called Kinetico Server. When I click that, it'll take me to the overview page for the server itself, and it'll reveal my server admin name that I named Adam. So this is the name that I need to put into Azure Data Studio. Once again, you can hover over this and copy it to your clipboard if it'll save you a little bit of typing. So I'll go ahead and do that. We'll switch back into Azure Data Studio and fill in the name. Finally, the password is established when you created the Azure portal database. If you forget what that is though, if we go back into the portal, you'll see that we have a link to edit that password. And it's right up here at the top. We can reset that password and create a new one if we need to. Okay, I'll go back into Azure Data Studio. I filled in the server name, the authentication type as SQL Login, the username Adam, and I'll fill in my admin password. I'll choose the option to remember the password, and we'll give our connection a name. I'll call it Azure SQL Database. Now I'll press the Connect button. After a moment, it prompts me to create a new firewall rule. This will give us permission for the computer to access the Azure SQL Database. For the Azure account, I'll click to Add an Account. That'll take me back out to the web, where I need to log into my Azure account again. Once I do that, I can go ahead and close the page and go back into Azure Data Studio. That'll fill in my account details right there. Next, I need to add in my client IP address. This is the IP address of the current computer that I'm working on, and I'll press OK. That'll create the firewall rule that'll give me access into that database server, and it'll add the new connection over here in the sidebar. It also opens up the database dashboard page in its new tab. Let me go ahead and just close that down, and we'll take a look at the database over here in the sidebar. Now, when I deployed this database in Azure, I set it up to include the sample database, and if I expand the name of the database right there, we'll see that it already contains tables, and we can take a look at the data and columns inside of those tables. So that's it. We now have a connection to our Azure SQL database that's being hosted on Microsoft's cloud platform. Now that we have some server connections in place, let's take a tour around the Azure Data Studio interface. The dark gray bar on the far left side of the screen is called the Activity bar. It has icons that represent the different sidebars that we can access. At the very top, we have the icon for the connection sidebar, which is the one that I'm looking at here. Clicking any of these icons a second time will hide the sidebar and give you more room to work on the main portion of the screen. Going back into the connection sidebar, you'll notice that when you hover your mouse over any of these icons, it shows you the name of the sidebar as well as its keyboard shortcut. These will be useful to memorize if you access any of these sidebars regularly. Below the connection sidebar, we have a sidebar for search. This will allow you to locate text within project files that you may be working on. To search, though, you need to set up links to folder locations on your computer. And you do that with the Explorer sidebar that's 2 options down. This one here with the 2 pages icon. Here, we can connect and browse files on our local computer. I'll choose the option here to open up a folder. And then I'll browse out to my desktop where I have the course exercise files, and I'll choose the Chapter 2 folder and say Select Folder. That'll then ask me if I want to trust the authors of the files in this folder. I'll go ahead and choose this checkbox there to trust all of the authors and choose the option that says, yes, I trust these authors. That'll give me access into those files. Then we'll just go back into the Explorer sidebar, and I can see that I have a connection to the Chapter 2 folder that's on my desktop, as well as all the files inside of that folder. If I click through any of these files, you'll notice that the text opens up in a new Editor tab over on the right. This allows me to read and edit these files directly here inside of Azure Data Studio. As I click through to the other files, you'll notice that the tab updates. Notice here at the very top that the title is written in an italic font. This means that this tab is kind of temporary. As you click through to other files, it simply updates with the next file. If you want to permanently open up any of these tabs, simply double-click on it here, and you'll notice that the font is no longer italicized. Now, when I click onto a second file, it'll open up in a new tab. This will allow me to easily move back and forth through different files within my projects. At the top, we also have buttons to add new files or new folders into the project. These will actually add files and folders into your file system, so changes that you make here inside of Azure Data Studio will be made onto your disk. There's also an option to refresh the Explorer in case you make any changes to your files outside of Azure Data Studio, as well as to collapse the folders here in case you have multiple folders added. You can add in additional folders by right-clicking anywhere in the blank area of the Explorer options, and we'll see that we have an option to add a new folder to the workspace, to open folder settings, or to remove an existing folder from the workspace. The Explorer sidebar can also be used to explore the different tabs that you have working with inside of Azure Data Studio. Go up here to the 3 dots menu next to the word Explorer, and we can see that we can also see our folders, which is what we have right now, an outline option, which is at the very bottom, as well as the option to view open editors. When I toggle that on, you'll see a list of open editors here at the very top. This simply shows me the different tabs that we have opened over here on the right. We have the option to add in a new tab by clicking this option there. That creates a new file right over there on the far right. We have the option to save all of the open tabs at the same time, as well as to close all of the editors at once. And this makes it easy to close everything and keep your screen nice and clean. So now that we have a folder connection here in the Explorer sidebar, we can go back to the Search sidebar and search through all of those text files. For instance, if I search for the text Kinetico, it'll now find that text in one of my files, the Kinetico db.sql file, and there's 3 instances of the word Kinetico. There are additional options to the right of the search box to control the search further. You can match specific casing, you can match whole words, as well as use regular expressions. Below that, you can also use a find and replace functionality, and replace words throughout your entire document. Now, between Search and the Explorer sidebars is an option for notebooks. Notebooks are a feature that allow you to create interactive code blocks and formatted documentation for processes that you want to execute regularly or share with other users. We'll take a look at notebooks in an upcoming chapter. There's also a sidebar for Git source control. If you're writing code and you want to save your projects to Git for version management, you can make use of this sidebar. Finally, we have the Extension Marketplace sidebar right there that we've seen previously when we added in the PostgreSQL extension. Now, if you find that you're not using any of these activities, you can right-click on the activity bar and choose to turn on or off any of those options. For instance, if you know that you're not going to be using source control, you can turn off the source control option and it'll simply remove that icon from the panel. This allows you to easily focus on just the tasks that are important to you. At the very bottom of the activity bar, we have additional icons that'll allow you to manage your Azure user accounts if you have any connected. Let's go ahead and close that panel on the right, as well as get into and manage the settings for Azure Data Studio. So those are all of the options inside of the activity bar. Let's now turn our attention back to the server sidebar, which is where you're probably going to spend most of your time. I'm going to go through and click on each of my servers to reconnect to each of those database servers. Now we can browse into the servers by expanding the different folders. So for instance, on my SQL Server on Docker server, I can expand the databases, then go into system databases where we have our system databases there, and I can see what's inside of each of those servers. There's also a right-click menu on each of our servers that contains useful information. For instance, I'll right-click on the SQL Server on Docker server and choose the option for Manage. That'll open up a dashboard for that server that reveals some useful information about the server, including a version of the software that we're running, as well as information about the operating system that it's on. Using that same right-click menu, you can also disconnect from a server connection that you've established. You can edit that connection, you can delete the connection, or you can refresh the connection if any changes are made, and that'll update the view that's displaying over here in the connection sidebar. The other most useful option in this menu is New Query. That'll open up an editor window for queries that you can start sending commands to the server itself. Notice that it's already made a connection to a specific database using this drop-down menu, but you can also use the drop-down menu to choose a different database that's on the same server. Now, each of these tabs that are opened up in the editor windows can be closed with the X in the upper right-hand corner. You can also click and drag on these tabs to rearrange them. So for instance, if I want the SQL editor to the left of the server dashboard, I can rearrange them that way. Also, if you click and drag one of the tabs, you'll notice that different areas of the screen start getting highlighted. So for instance, if I move it over here to the left, or I can move it over here to the far right, or I can move it down towards the bottom. If you drop this on any of these shaded areas, it'll open up in a new tab group. This allows you to view multiple tabs on the screen at the same time. There's also a button to do the same thing over here on the far right. That'll open up different split editors in different tab groups. For instance, I can add in a third column over here on the right and view 3 files at once. So let me go over here and I will get rid of this tab. I'll just right click on it and say Close All. That'll close all of the tabs in that particular view. Then I'll take this tab and I'll just drag it back to the first one, and that'll collapse my tab group again. If instead of horizontal groups, you wanted to do things vertically, you can Alt or Option click on this button here, and that'll split tabs vertically. So now I have 2 groups, one here at the very top and a second group at the bottom. This allows you to rearrange the screen however you want and make it easy to copy information from one file to another. I'll go ahead and close this tab on the bottom, and that'll just return me back to the single tab group. Finally, at the bottom of the interface, we have a status bar down here on the very bottom. It's blue right now. On the left are a pair of useful icons that display any errors or warnings that your server wants you to know about. If you click on this, that'll open up the problems window that might give you some additional details. Luckily for me, though, I don't have any problems at the moment. Let's close the problems panel by clicking on this X over on the right. On the right of the status bar is some additional server information. We also have a feedback icon that will allow us to tweet directly at the Microsoft Azure Data Studio Twitter account. And finally, we have a bell icon that'll show me notifications about the program or any updates that Microsoft wants me to know about. So that's the main Azure Data Studio interface. It's a clean, compact arrangement of tools that I think is well organized, which makes it easy to manage your databases and all of your data projects. So far, I'm connected to a SQL Server instance and a PostgreSQL database server, both running inside of Docker, as well as an Azure SQL database that's hosted in the cloud. I can browse all 3 of these locations simultaneously here inside of the server's sidebar. Now, these aren't the only data sources that Azure Data Studio can connect to, though. At the time of recording, Azure Data Studio also supports connections with Azure SQL Managed Instance, Azure SQL Data Warehouse, and SQL Server Big Data Clusters, as well as Oracle databases. Microsoft also promises that even more data sources will be supported in the future. Azure Data Studio wants to be the hub of all of your various data sources, no matter what platform they're on. But with so many connection options, it's going to be important to keep the server sidebar organized. And you can do that by grouping your connections together. To do that, we'll come up to the very top of the connection sidebar and click on this icon here with the folder and a plus symbol to create a new server group. That'll open up a panel over here on the right where we can name the new group. I'll call my first group Local Databases. We can add a group description if we'd like, and choose a group color. I'll choose this green color there, and press OK. That creates a new description label right here at the very bottom of my server sidebar. And now all I need to do is drag the connections that I want into this collection. So I'll click on the SQL Server on Docker server connection, and drag and drop it into local databases. And we'll do the same thing with the PostgreSQL connection. I'll drop it into the same folder. Now let's create a second folder for my cloud-hosted databases. We'll name the server group Cloud Databases. And I'll choose a blue color for this one and press OK. That adds one more group into my server sidebar, and I'll drag the Azure SQL Database connection into that group. So now I have an easy way to manage my different database connections depending on where they are. I can easily collapse each of these connections and keep my server sidebar clean. Then when I want to work with just my local databases, I'll expand that one open, I'll see them both right there, and I can expand or collapse any of these as I want to work with them. You can also nest groups inside of each other by dragging them together. Let's create one more group here, and I'll call it SQL Server Databases. This time I'll choose this pink color chip and say OK. That adds in a new folder there. Then I'll drag and drop this one into my local databases. And then I'll take the SQL Server on Docker database and drop it into that. If I had additional SQL Server databases, I could put it into the same folder. Now within my local databases, I have a separate collection of just my SQL Server databases. If you want to modify the group name or choose a different color, simply right-click on it and choose Edit Server Group. And that'll bring you right back to this window. Let me press Cancel. Also, you have the option to delete a group. But if you do this, it will also delete the connections that are currently inside of the group. So before you delete any of your groups, make sure you drag any connections out of that group that you want to keep. So I'll take my SQL Server on Docker connection, I'll drag and drop it back into local databases, and then I can right-click on the SQL Server Databases group and delete that group. So with server groups, you can bring some organization to your sidebar and make it easy to quickly locate the data connections that you need. This is particularly useful if you have collections of servers for specific projects, or if you work with a variety of clients and want to keep all of their data sources grouped together for easier management. Backing up and restoring databases from backups is a critical task that anyone working with data should be able to perform. This functionality is built into Azure Data Studio through each server connection's dashboard. You can get to them by right-clicking on a server connection, for instance the SQL Server connection, and choosing Manage. Here at the top, you'll find a button for Restore, and often you'll see one for Backup as well. But I'm not seeing that one right now simply because I don't have any user databases. So let's add one to our SQL Server instance. I have the SQL code that we need saved inside of the exercise files for the course. You can open up that file in a couple of different ways. One option is to go to File, Open File, then browse into the Chapter 2 folder where you'll find the kineticodb.sql file, selecting it and pressing Open. That'll open that text file inside of its own tab and connect you into the database. So this is the code that I want to execute. The other way of doing that is to close this tab first, and since we already made a connection inside of the Explorer sidebar to the Chapter 2 folder, you'll find all of the same files right there. You can simply click on that file, and again, it'll open up in its own tab. I prefer to do it this way so that I'm staying within the same application through the entire process. Now, when you open up this file inside of its own tab, you definitely want to double check that the server that you want to execute it on is the one that's currently selected. This file is connected into my SQL Server database. You can verify the ports and the name right over there. However, if it accidentally connected to one of your other servers, you can choose the disconnect option here or the change connection option there. I chose disconnect. I can then press connect again. I'll choose my SQL Server on Docker server and press connect, and it should reconnect it so that it's executing on the appropriate server. Then, with the selection targeted to the master database, I'll simply press the Run button. That'll go through and create the database. It'll then use that database and create a new table and fill it with some values. At the very end of the script, it's simply selecting everything from the new table that we created, and it's showing me the results right here. So now I have a user database on this server. Let's go back to the connection sidebar. I can then right-click the server connection and choose Refresh, then go into the Databases folder, and we'll see that database right there. All right, let's close these tabs, and we'll go back into the Database Server's dashboard. Here, I'll press the Refresh button. Then I can go down into the Databases folder where we'll see our database list there, and there is the new Kinetico database. I'll double-click on it to open it up, and then I have the option to back up this database. Clicking this button will open up a new Backup Database panel on the right side of your screen. We can fill in the name for our backup, the recovery model, as well as the backup type. We could choose to make it a copy-only backup if we wanted to, and we have the file path where it's going to save the backup file. Keep in mind that the file path that you're seeing is on the database's server, which might be different than your local computer. In my case, this file path is inside of the Docker container. If your server is running on a Windows computer, it's going to be pointing to a different location. Scrolling down on the screen, we have some additional options to set compression, encryption, as well as create media backup sets. You can set any of these backup options however you want. I'll simply leave all the defaults and press backup. And that'll create the backup file inside of the Docker container. The task history sidebar opens up automatically so you can keep track of the progress. Now, this is a pretty small database, so it's not going to take any time at all to back up. If you want to see the command that was issued to the server, you can right-click on the task and choose Script. That'll reveal the exact SQL code that was sent to the server in order to back up your database. So you can see it was a simple backup database Kinetico command, and we have the file path where it's saving all that out. So now we have a backup of the database that can be restored should anything go wrong. Database backups aren't much use unless you know how to restore them back onto your server when they're needed. I want to show you how to do this in Azure Data Studio, but rather than just restore the backup of the Kinetico database that we just made, I want to use this feature to add in a new second database onto my SQL Server instance. Let's right-click on the server and choose Manage. Then on the server's dashboard, I'll press the Restore button. That opens up a new panel, and I'm going to choose to restore from a backup file. And then we have the backup file path. Press the ellipsis button, and that'll open up a new panel that'll allow us to browse the file system. However, if you take a look at this, you might realize that this isn't the file system of your local computer. This is the file system of the database server. And in my case, that means this is the file system inside of the Docker container. The specific folder that it's looking in is var opt mssql/data inside of this container. So this is where I need to place my backup file in order for it to be found. I'll press the discard button, then I'll press the cancel button, and that'll take us back out to the dashboard. Let's now go out to the file system and copy the backup file into the appropriate location. In the Chapter 2 folder, I have a backup file of the 2trees database called 2trees-SQL-Server.bak. The command that I need to use in order to copy this file off of my local file system and store it inside of the Docker container can be found in dockerbackup.txt. And here's that command right there. The specific command is dockercp, the path to the backup file on your local file system, then the name of the container, in our case I named it SQL Server, : and the file path inside of the container. So this is the command that we're going to execute. And remember, you do this inside of the PowerShell window or in the terminal application if you're on a Mac or Linux computer. I'm going to rearrange my screen a little bit so I can see both the PowerShell window as well as my Chapter 2 folder. Then we'll start the command. Docker cp the file path on my local system, and for that I'll just drag it out of the Chapter 2 folder and drop it in PowerShell, and that'll put in the full path. Then the name of the container, SQL Server, colon, and the file path inside of the container. That's /var, /opt, /mssql, /data, / the name of the file. 2trees_SQL The only tricky bit to this command is to remember that on the Windows file system, it uses backslashes in between all of the different folders, whereas on the Linux file system inside of the container, it uses // between the different folders. All right, with that full command in, I'll press enter, and that'll copy the file off of my local system and place it into the container. All right, that's done. Let's go ahead and close out of PowerShell. I can also close the Chapter 2 folder, and we'll return back into Azure Data Studio. Once again, we're back at the SQL Server dashboard. I'll press the Restore button. We'll restore from a backup file. Then I'll click the ellipsis to choose the backup file path. I'll scroll down through the list here until I get to var opt mssql/data, where there is the new 2trees backup file that we just copied in. Incidentally, you'll also find the Kinetico backup file that we created in the prior movie right there. If you wanted to retain a copy of this, you would want to copy it out of the container to store it on your local system. Okay, but we're looking at restoring the 2trees database, so I'll make sure that's selected and I'll press OK. Then I'll press the Restore button at the bottom of the screen. That'll go through the process and restore the database onto my SQL Server instance, and you'll see a line here in the Tasks panel. Once again, you can right-click on this task and choose Script if you wanted to see the exact SQL code that was issued to the database server to restore that database. Let's go ahead and close all of our tabs, including the dashboard. We'll come back over to the connection sidebar. Now I can right-click on the server and choose Refresh. And then if I expand the Databases folder, you should see our new 2trees database right there, and all of its tables inside of it. So that's how you can restore a database backup in Azure Data Studio. The only thing that you need to remember is to copy the files for your backups onto the server itself. It'll either be inside of a Docker container like we just saw, into the cloud if you're using a cloud-hosted server, or into the file server itself if you're using a local on-premises server. The Explorer sidebar is great for collecting links to all of the files that you need for a specific project. This makes them easy to get to right here inside of Azure Data Studio, no matter where they may be scattered around on your actual file system. Together, this collection of files is called a workspace. We've previously added the Chapter 2 folder of the exercise files here, and you can right-click and add in additional folders to the same workspace to add in additional files. You can think of these collectively as a single project, and all of the files for that project will be the code that you need for the specific project. Now we can save all of this as a workspace file, which allows us to create new workspaces for different projects, and then switch back and forth between them whenever we need. Go up to the File menu, and then choose Save Workspace As. This will prompt me to save a file with the .code-workspace file extension there. I'm going to go into my exercise files, into the Chapter 2 folder, and I'll make a new workspace file called Chapter 2. Now I'll save it, and I have an easy way to get in and out of that workspace. After a moment, Azure Data Studio will reload itself, and you'll notice that the title bar here at the top changes slightly, but there are all of my Chapter 2 files again. If I switch back over to the connection sidebar, you'll see that we still have access to all of the same connections, although they've become disconnected. So in order to reconnect to them, you just simply need to click on them once to reestablish that connection. Okay, let's go back to the Explorer sidebar. So I can continue working on this workspace and adding in additional files or folders or whatever I need for this project. When I'm done, I would simply go up to File and then save the workspace again. When you're done working in this workspace, we can close it. In the File menu, towards the very bottom, you'll find an option for Close Workspace. That'll reset your Azure Data Studio environment, and if we go back to the Explorer tab again, you'll see that our links to all those files are now missing. However, back in the Server Connection sidebar, all of our server connections are still there. At this point, we can start setting up the files for our second project here in the Explorer window. Simply add in new folders and new files to this new workspace. When it's time to go back to your first project, go to the File menu, choose Open Workspace, and I'll go into the exercise files, Chapter 2, and we'll reload the Chapter 2 workspace once again. Again, Azure Data Studio is going to refresh its screen, and it puts us right back to work, and there are access to all of our files again. So that's the Workspace feature. It allows you to group project files together and quickly switch between different collections of files to help you move between the different tasks that you need to perform. Management of any relational database requires you to write and execute commands written in SQL, or structured query language. To get the most out of Azure Data Studio, you're going to need to be familiar with reading and writing SQL queries. But the program will help get you started, and you can easily save and reload existing script files so that you don't have to write everything out every single time. Now, previously, I loaded a copy of the TwoTrees database onto our SQL Server instance. I'd now like to add in a copy of that database into the PostgreSQL server as well. I have the full SQL script to do that saved in the exercise files. Let's create a new workspace for Chapter 3 now to make it easy to access this file. To start, click on the Explorer icon over here on the sidebar. If you have files here from the previous chapter, you'll need to go up to the File menu and then choose Close Workspace to reset it. Now, I'll press the Open Folder button, I'll browse into my exercise files, I'll choose the Chapter 3 folder, and press Select. That'll reload Azure Data Studio, and I might need to go through and reconnect to my database servers. Then we can flip back over to the Explorer sidebar, and there's all my Chapter 3 files. While I'm at it, I might as well save this new workspace so it can be reloaded quickly in the future if I need it. To do that, go up to the File menu, choose Save Workspace As, and I'll save a copy of it into the Chapter 3 folder, and I'll call it Chapter 3. That'll place that file right into that folder, and there's that code.workspace file if I ever need to reload the workspace. Okay, so now let's go ahead and turn our attention to recreating the TwoTrees database on the PostgreSQL server. The script that I have for that is called TwoTrees-PostgreSQL.SQL. You can double-click on it to open it up in a new editor tab. Now, I'll also point out that there is an additional copy of this file called TwoTrees-SQLServer.SQL, and you can use this file to recreate that database on the SQL Server instance in case you weren't able to load the backup file in the previous chapter. There are slight differences in the SQL language between the two platforms, between PostgreSQL and SQL Server. That's why there's two different versions of this file, depending on what platform you're going to run it on. So make sure that you load up the file here for PostgreSQL, and we'll execute it on that server. Now, the first thing we want to do is make sure that we connect to the appropriate database server. So up here on the top, you can either press the Change Connection button if it's connected to a server, or since mine isn't, I'll press the Connect button. Then I'll choose my PostgreSQL on Docker server from the recent list and press Connect. Then I want to make sure that I'm targeting the Postgres database to start. This script file will run through all of the steps of creating a database and then filling it with data tables and rows of data. The first step is to create the empty TwoTrees database. Now, I don't want to execute this entire script all at once. So what I can do is highlight just line number 2 and execute that by itself. By highlighting it first and then pressing the Run button, it'll execute just that single line. Then in the drop-down menu for the server, I should see that my new TwoTrees database has been created right there. Now I can run all of the additional commands in this file in order to create those tables and add in the rows of data. To do that, I'll highlight everything from line 3 all the way down to the very end, which is on line 326. I'll press the Run button again, and it'll create the tables and fill it with the data, and you can see the results here being displayed in this grid. At this point, we're done executing the file, and I can go ahead and close the tab. Next, I'll switch over to the connection sidebar, and we'll take a look inside of the PostgreSQL server just to make sure that we have our new database. There it is. I can expand it. I can expand the tables, and there are the 5 tables that we just added using that script. So now we have a duplicate copy of the 2Trees database on the PostgreSQL server. The saved workspace makes it easy to access all of our related scripts, and we can save, open, edit, and execute them on any of our connected database servers. One of the most common tasks that you'll need to do with any data table is review the data that it stores. You can do that by writing a select query, and Azure Data Studio has a way to get you started with a new query built right into the right-click context menu. Let's take a look at the Kinetico database that's on the SQL Server instance. We can expand the database, and then we can expand the tables folder, and we'll see that this database only includes a single table called dbo.department. Expanding the table will reveal its contents. Here we can see that this table is made up of 3 columns. We have their column names, their data types, and any other constraints on each of those columns. We can also see if it has any keys, and this one does. It has a primary key on the department ID column. We can also see if it has any constraints, triggers, indexes, or statistics by expanding each of those folders. So these are all the components that make up the structure of the data table, but in order to actually see the data that's being stored, what we can do is right-click on the name of the table and then choose Select Top 1000. This will open up a query in a new Editor tab, and we have the 4 lines for the select query here at the very top. It also automatically executes this query, and we can see the results down below. So this query is a select query. It's selecting the top 1,000 rows, including the department ID column, department name column, and the building column, from the table in the Kinetico database, the DBO schema, and the table named department. The results show me that I only have a total of 8 rows in this data table, but I can see each of the 3 columns there, and if you needed to, you could scroll through the list if it was longer. Next to the Results tab is a tab for Messages. This will give you some useful information about the execution of the query. We can see what line it started on, how many rows were returned, and how long it took the system to return the results for the query. So this will get us started selecting the data out of our data table. We can also use this query as a base and edit it to further meet our needs. So let's modify the SQL script at the top to take a different look at this data. Instead of seeing all 3 of these columns, what if I only wanted to review just the departments in the main building? I could change it from a Select Top 1000 query and just select the department name columns, and I'll get rid of all of this space, including this comma. We'll select the department name column, comma, building column from the same table, and I'll add a where clause to the end, where the building is equal to main. To execute this query again, I'll come up to the top and press the Run button, or press the F5 shortcut key. That'll re-execute this new select statement, and I can see just the departments that are in the main building. Now sometimes your select queries can get complicated, and in fact, they might actually take a long time to run. If a query is running for an extended period of time and you want to end that process, you can come up to the top and press this Cancel button. You'll also definitely want to pay attention to this connection box over here on the right. This displays the name of the database that your select query is being executed against. Right now, we're running this select query against the Kinetico database. But if you needed to change contexts, you can use the drop-down menu and choose a different database on the same server. If you wanted to change the connection, you can press the Change Connection button here and choose a completely different server in order to target this select statement against an entirely different server and a different database. I'll just press the Cancel button, and we'll make sure that we're still targeting the Kinetico database on the SQL Server instance. Now in this dataset, we have several departments within the same building. It could be useful to find out how many departments are in each building. We can quickly get to that information by making some changes to the query and adding in an additional clause. I'll remove the where clause on line number 4. Then I'll add a count function before the department name. I'll open up a parenthesis, come to the very end, and close the parenthesis. Let's also give this counting column a new name. I'll call it as, and in double quotation marks, number of departments. We'll still pull the building column, so I'll leave that alone, and it'll be from the same table, so we'll leave that line alone. Then we'll come down to the very end, and on line number 4, I'll type in group by the building column. Notice as you type, the IntelliSense pop-up window starts giving suggestions based on your syntax and the contents of your database. If you see the item that you're typing, you can use the arrow keys to select it and press Enter to fill it in automatically. This feature can save a tremendous number of keystrokes when you're writing your own queries once you get used to it. So now this query is going to aggregate all of the records that have the same building name together and allow us to count up how many departments there are across each group. Finally, I want to add in a sort to the dataset so that I get the buildings with the highest frequency appearing at the top. I'll get that to line number 5 and I'll add order by the count of the department names. I've typed in a couple of characters here and I see the value that I want in the IntelliSense pop-up window, so I'll just arrow down and press Enter to fill that in automatically. Then I'll come down to the end and I want to add the text descending, DESC, and we'll press Enter to finish the query. So there's my final query here. Let me go ahead and scroll this down and so I can see the whole thing there. I'll press the Run button and I can see that the main and the south building both have 3 departments, and the Taft and Watson buildings both have 1 department each. Now, if this is a query that you'd like to run regularly, you can save it by pressing Ctrl or Command S on your keyboard, or simply try and close the tab and you'll be prompted to save it. Let's go ahead and save it into the Chapter 3 folder. I'll call it buildingcount.sql. To reload and run the script again later, you can either use the File Open menu, or if you're taking advantage of workspaces, you can switch over to the Explorer sidebar, where you'll find that SQL file that we just saved, double-click on it, it'll reopen it, and you can rerun it anytime you like. For SQL Server databases, Azure Data Studio includes a graphical table design tool that allows you to build new table structures without having to write out all of the SQL commands to create one from scratch. Let's use this tool to add in a new table into the Kinetico database on the SQL Server instance. To access the tool, just right-click on the Tables folder and choose New Table. That'll load the graphical table designer. Now, Azure Data Studio at this point in time considers this a preview feature, and you can see a notification of that in the upper right-hand corner. If you're not getting the option in your right-click menu to create a new table using this graphical designer, then come down to the gear icon in the bottom left-hand corner and choose Settings. Then do a quick search for Preview Features, and make sure you have a check mark in this box here for the workbench Enable Preview Features. That'll give you the option in that right-click menu to open up this designer. So now we can use it to create a new table and add it to the Kinetico database. I'll name this table Employees. Then we'll come down where we have the column definitions and start filling in the details for each of the columns. I'll click the first placeholder column that says Column 1 here, and I'll call it Employee ID. I'll leave the data type set to integer, but I'll make it the primary key by placing a check mark here. On the right-hand side of the window, we have some additional column properties that we can fill out. Let me scroll down through this list, and one of the properties is identity. When I check that on, that'll set the identity seed to 1 and the identity increment also to 1. This will allow SQL Server to automatically create identification numbers for each new employee as they're added into our database. Now we can add in a second column to this table's design. Come back over to the left and click the New Column button. This column I'll call Employee Name. For the data type, go ahead and click there and then use the drop-down menu to choose one of SQL Server's data types. I'll choose the varchar 50 data type. Then in the column properties over on the right, I'll scroll back up here to the top, and I'll change its length from 50 to 100. That'll set its data type to an nvarchar 100 instead. So that sets up two columns in our new employees table. There's additional tabs in this designer. We can go over here to the primary key tab, and it'll confirm which value or which column we're using for the primary key of the table. We can also add in additional columns if we want to create a concatenated primary key. We can switch over to the foreign keys tab and add in foreign key relationships to other tables in the database. We can also add check constraints, indexes, and on the general tab, we have some additional properties for the design of our table. So we can fill out all of the details for our table, and when we do so, it fills in this script down here at the bottom of the screen. So this is the create table syntax that's going to be needed in order to create this table on the database server. It has the syntax for all of the properties that we've chosen. When you're ready to deploy this table onto your server, come up here to the very top and click this nondescript button that's called Publish Changes. That'll give you the option to preview the changes that are about to be made. In this case, we're going to create a new table on our database. Press the Update Database button at the bottom, and your table will be created. Now we can close the Employees tab right here at the very top and take a look at the database. I'll right-click the Tables folder and choose Refresh. And there is the new Employees table, and there are the two columns inside of it that we've just created. Now you can also use the visual editor to modify the structure of existing tables. Right-click on the DBO department table, and this time choose Design. That'll open up this table and includes all of its existing columns in that graphical editor. Now we can make changes to the design of this table. I'll scroll down in this list of columns and choose the Building column, and then scroll over here to the right where we have the default value property. Let's put a default value for the building as South. We need to do that in single quotation marks. That'll add that default constraint down here into the script for this table. And now I just need to come up here to the very top, click the Publish Changes button, then update the database. Now the department table will have a default constraint that'll automatically apply the South building anytime we create a new record. Let me close this tab and we'll test it out. I'll right-click on the Kinetico database and choose New Query. Then we'll insert a new record into the table. We'll insert into the DBO department table, and we'll fill in the department ID and department name columns. Then we'll put in the values, 900, and the department name Sales. I'll run the query, and that'll insert a new row into the table, and now I can highlight all of this and just do a simple select statement. We'll select everything from the DBO department table. And here at the very bottom, we can see the new record that we just entered for the sales department, and we can see that it was automatically placed into the South building. So using the graphical table editor for your SQL Server databases makes it easy to create new tables in the server, as well as to edit existing tables and add additional constraints or other parameters. Adding and editing data in a table can be performed with SQL insert and update statements written in the standard Query Editor tab. Or you can use the graphical interface in Azure Data Studio to help you locate and update records without having to write any code. Let's take a look at this feature by adding and editing records in the department table for the Kinetico database. I'll right-click on that table and choose Edit Data. In the tab that opens up, we get a tabular result of all of the records that are in the table. Now this looks similar to the results that you get when running a select query. However, unlike the results of a standard query, these values in this table are editable, and changes that you make will get saved back to the data table. For instance, I can change the building for the account management department from the main building to the West Campus. As soon as you press enter, that data change is made to your table. To prove this, let's go back into the department table, once again in the server connection sidebar, and I'll right-click and choose Select Top 1000. This will run a standard select statement, and we can see the change that I just made is already reflected in the results over here. Okay, let's go back to the other tab where we can edit our values. At the top is a button that'll show us the SQL pane, and this will reveal the select statement that's currently pulling out these records. This can be helpful for locating specific records that you want to change. We can just modify this select statement, and it'll update the table down below. Now this table doesn't have very many rows, so it's easy to see everything right now, but assume that there are thousands or millions of rows of data here. We can quickly limit the results to just Department 400 with a where clause. I'll add that to the end. On line 5, I'll type where department ID is equal to 400. Now when I run this select statement, it'll filter the results to just that single row. Now I can quickly make a change to the department name. Instead of just the text Human Resources, I'll add HR in parentheses to the end. I'll press Enter, and that data is saved to the table. Using this technique to filter the results to just the rows that you want to edit can make sure that your edits are going into the correct place. At the very bottom of the results window, you'll also notice a row that has null values all the way across. This represents a potential new row that you can add into the database. For instance, I'll fill in a new department, 1000. I'll press Enter, and that new row gets added. Then we'll click over here into the department name field. This new department is Research and Development. Previously, we added in a default value for the building, so South is automatically added for us. You can either accept that value and leave it there, or you can change it if you need to. I'll click that value, and I'll put the Research and Development department inside of the Taft building. Once again, pressing Enter will save those values. Alright, at this point we can go ahead and close this tab, and all of our data changes have been made. And just as a final check, let's go ahead and re-execute this select statement in the other tab, and it should update to show me all the results. If we take a look at the departments, we should have a new department name for Human Resources. Let me just double click there to make that wider. So there we go, they have the HR in parentheses there. And here is our new department, Research and Development, added to the very end. So with the graphical data editor, you can update tabular data in Azure Data Studio without having to write out a single insert or update SQL command. There are two additional options in the right-click contextual menu for SQL Server tables that I want to look at. Right-click on the department table, and you'll see Script as Create and Script as Drop. Let's take a look at Script as Create first. That'll open up a new tab on the right, and it'll be the exact syntax for all of the commands that will recreate this table's structure. This can be useful if you need to make a copy of the table, or if you want to update the documentation about how your database was developed. This script includes all of the column definitions, primary and foreign key constraints, default values, indexes, and check constraints. It does not, however, include any data, so keep that in mind that this script is only for the structure of the table. Now, if you want to duplicate the table in your database, simply change all occurrences of the name. I'm going to create a copy of the department table, and we'll call it Department New. You'll need to change the name on line number 5. I'll just add an underscore new to the end there. Also on line number 11. And finally on line 16, we'll change it there as well. With those 3 changes made, I can run this script, and a copy of my table is immediately created. Let me go over to the Connections sidebar. I'll right-click on the Table folder and choose Refresh. And there is the duplicate copy of the table. I can expand it and see there's all those columns. So that's what Script as Create does. Let's go ahead and close this tab, and we'll take a look at the other option. I don't need to save the changes to the script. Now I'll right-click on the Department New table, and this time choose Script as Drop. This script is much shorter, and it simply removes the table from the database. It'll also delete any data that it may contain. If you want to execute the script, press Run, and that table is immediately removed from your database. Right-click on the Tables folder and choose Refresh, and you'll see that it's gone. So obviously, you'll want to be very careful with this script, Because the change is immediate, and the only way to undo that operation is to restore your database from a backup. Now, it's not often that you'll want to copy or drop a database table, but those two scripts are handy built-in features when you need them. Azure Data Studio makes it easy to export your data from your databases and send it to external files so that you can import them into other programs, such as Excel, for further exploration or visualization. Let's take a look at the data that we have stored in the TwoTrees database this time. I'm going to expand this and expand the tables, and we'll find the inventory.products table. Let's right-click on it and choose Select Top 1000. So here we have a lot of product data, and I want to actually filter this list down just a little bit more. So I'm going to edit this query up here at the top. I'd like to sort these records by price so that the highest price product are listed on top of the results, and then also limit the results to just Category 2 products. So we'll start with a where clause, where the category ID is equal to 2. And then we'll add an order by clause, and order by price descending. When I rerun the query, it'll update the results down below. So this is the data that I want to export to an external file. We can do that with the first 4 icons over here on the right. They are export to a CSV file, which is a comma-separated values plain text file. We have an option to export to an Excel file. We can also export to a JSON data format, which stands for JavaScript Object Notation, and it's a common data format used on the web. And finally, we have the option to export it as an XML file, which is also a common data format used on the web. So let's export this data as a JSON file. Come up here and click the icon with the curly braces and the arrow. That'll prompt me to save the file, and I'll just leave it with the default name of results.json, and we'll store it into the Chapter 3 folder. I'll press the Save button, and it immediately opens up in a new tab over here on the right, so I can see those results. In the JSON file format, each record is contained within its own set of curly braces, and then inside of those we have the key value pairs that capture all of the column values. So these 4 file formats, CSV, Excel, JSON, and XML, will cover the vast majority of cases when you need to export your data from your database and import it into another program or share it with your colleagues. Remember to write out a select statement that returns only the records that you're interested in, and then hit one of these 4 buttons on the right to save those results to disk. Azure Data Studio includes a neat little charting feature that allows you to quickly visualize your data. Let's take a look by loading a query that I just saved into the Chapter 3 folder, and I'll flip over here to the Explorer sidebar to find it, and it's called salessummary.sql. This will return the total sales amounts for each day that have orders. Make sure you're targeting the TwoTrees database, and then run the query to see the results here. So here we have a row being returned for each day we have sales, and then we have the total sales value for that day. Next, over on the far right side where we have the export options to our different exportable files, the last icon here at the bottom will open up a chart. Go ahead and click that. Now you may be prompted to install an additional extension. We'll take a look at this in just a moment, so go ahead and just press the X to dismiss this notification. So this is the basic charting functionality that we have available. Let me go ahead and rearrange my screen a little bit so we can see it a little bit in more detail. On the right, we have a bunch of different options. We have some different chart types that we can make use of, and all the usual suspects are here. We have an image, donut, pie, bar, horizontal bar, and so on. I'm going to leave mine set to bar. I'll also check this box here that says use first column as row label, and that'll rearrange the chart just a little bit like that. So this is a basic chart that allows me to visualize our data. If I hover my mouse over each of these bars, I'll get a pop-up that tells me the total sales for that day. So here is October 31st at $172.89. And then we have October 30th at $74.94. At the very top, we have the legend that corresponds to all of the different colored bars and the exact day that they represent. Now, unfortunately, changing the color of your chart and incorporating these labels directly into the chart isn't really a feature that's supported at this time, so you're just going to have to be happy with the colors that come by default. I'm hoping that additional customization options is something that gets added into the program in a future update. For now, there's limited customization available here, and certainly this feature is not as flexible as something like Excel for charting, but you can get some limited information and a quick visualization of your data. If you do like what you have here, you can come up here to the very top. Let me scroll back up to the top, and there's a button to save this out as an image file. You can then use that image in a PowerPoint presentation or post it online. So this is the built-in charting functionality. I'm hoping this feature continues to get improved upon, as it really is useful to be able to visualize your data right here in the same program that you're already using. For more features though, we can take a look at one of those extensions. Let's go over to the extension marketplace by clicking this icon over here in the sidebar. Then we'll do a search for something called Sand Dance. This will use Microsoft's Sand Dance technology to visualize our data. I'll go ahead and select it, and we can see that we have a nice little animation going on down here that gives us a preview of what this add-on is capable of. I'm going to install this add-on, and that'll take just a moment to add that into my installation of Azure Data Studio. Now I'll close this tab, and we'll go back into our Explorer tab. Once again, I'll run the sales summary, and I'll press the Run button to execute the query. Now if we take a look at the options over here on the right, we'll see we have an additional option that's called Visualizer. This will make use of that Sand Dance extension that we just installed. Now it's a little bit scrunched up on my screen over here, but we can go ahead and try changing some of these properties and see what we get. I'm going to change it to a bar chart here. You can see it updates over on the right. Then I'm going to scroll down and find the total by and change this to sum strip layout. And now you can see the chart update to give me the same bars that we saw previously. So here's October 31st at $172.89. Now the pop-up flag is a little bit redundant. It gives me the order date again. If I scroll down a little bit farther here, we'll find a button for tooltip columns. And here I can turn off the tooltip for the order date. I'll press close. And now when I hover over the bars, it just shows me the total sales instead of both the sales value as well as the date. Now there's a lot of different options here. I'm not going to go through all of these, but I will flip over here to the color palette, and we can change the color. Let me go ahead and scroll up, and we'll change our color scheme. We have lots of different gradients that we can choose from. I'll choose this option, blue-orange. You'll see the color bars update. We can also reverse those colors so that orange represent the lower values and blue are the higher values. When you're done working with everything, you can go ahead and press this little shutter button to close that area over on the right, and we'll have our chart take up more room on the screen. So this is how the Sand Dance add-on works. You can see it gives you a lot more flexibility than the built-in visualizer. Now, unfortunately, I don't think there's a way to export graphics from this chart extension, but you can take a screenshot if you'd like to capture the chart for use elsewhere. So those are two built-in charting options for visualizing data in Azure Data Studio. For basic charts, they can be useful for getting a quick look at your data, but for anything that requires more flexibility, I'd suggest using the Export to Excel feature and building more complex visualizations there. The time that it takes to write some common database queries can be dramatically decreased through the use of code snippets. Snippets are pre-written blocks of SQL code that generate the proper syntax for a variety of tasks. Let's use the snippets feature to add another table to the Kinetico database, and this one will store product details. Right-click the Kinetico database in the SQL Server instance and choose New Query. A blank Query Editor tab opens up, and it's automatically connected to the proper database. Now for the magic part. Snippets are accessed through the IntelliSense suggestions, and they all start with the letters SQL. In the suggestions that pop up, you can see all of the snippets that we can choose from. Arrowing down through the list will reveal a short description as well. We can add a column to the existing table, create a new database, create an index, or a stored procedure. I'm going to scroll down until I get to the one called SQL Create Table. Once it's highlighted, press the Enter key, and the syntax for a new table is added into our editor window. The snippet code starts with a couple of comment lines, and then it goes through and verifies the database doesn't already have a table with the same name as the one we're going to create. If it exists already, the query will delete it first. Then, the create table statement starts with the column declarations inside. Notice that all of the placeholders for table name and the schema DBO are highlighted. You can fill in all of those placeholders with your custom name all at once. I'll type products to name the table. You'll notice that all of the instances of the name get updated simultaneously. Then press the Tab key on your keyboard to highlight all of the instances of the schema, which currently reads DBO. We haven't created any other schemas in this database yet, so the default DBO will work out just fine for us at this point. Press Tab again to select the first column that'll make up the table. I'll rename this to Product ID. Press Tab to define the second column, Product Name. Press Tab again, and that'll highlight the data type for the second column. I'll accept the suggested data type of nvarchar50. Press Tab again, that'll go down to the column 3 placeholder, and I'll call this column Price. Then I'll press Tab. Once again, I'll press Tab. The data type for the third column gets highlighted, and I'll change this one to Small Money. When you press Tab again, all of the placeholder text becomes deselected, and you can further refine the snippet to meet your needs, such as adding in additional columns for the table. I actually want the product ID column to generate a sequential ID number automatically. So I'm going to come up here after the int, but before not null, and type in identity, and in parentheses, 1, 1. So the product ID column will be an integer data type. It'll auto-populate with an identity value starting at 1 and incrementing by 1 for each new record. It won't allow any null values, and it'll be set as the primary key for the table. With everything filled in, all we need to do is come up to the top and press the Run button. The message area shows that the query completed successfully, and we can go ahead and close the tab now and not save any changes. Now I'll go back into the Kinetico database and expand it. There is my tables folder, and I'm not seeing our new table yet, so let's right-click on that and choose Refresh. And there is the new products table with the columns inside of it. So with snippets, you can speed up the task of writing common database queries. Just type the letters SQL anywhere in a query editor, and pick the one that you want from the pop-up list. Built-in code snippets provide a lot of functionality for common tasks, but custom snippets can also be created that are unique to your specific database's needs. To build our own snippets, we need to use something called the command palette. We're going to talk about this fantastic little feature later on in the course, but for now, just press Ctrl or Command-Shift-P to open up the command palette. It's basically a shortcut menu to every feature in Azure Data Studio. Then type the word snip, and that'll reveal the preferences to configure user snippets. Press Enter, and we'll go into that workflow. Next, we need to select the language that we're going to use. The snippets feature comes over from another Microsoft application called Visual Studio Code. So there's lots of language choices here that really don't pertain to Azure Data Studio. We're going to stick with the SQL option. You can either scroll down on the list with your arrow keys until you find it, or you can simply type in SQL in the Select Snippets up here in the search bar, and it'll jump right to it. But I'm almost there. I'll go ahead and select it, and press Enter. That will open up a file called sql.json in a new tab. This JSON data file is where we can create our customized snippets. There's a bunch of comments up here at the top that describe the makeup of a custom snippet. We'll need to provide a name, prefix, which will be the trigger that shows up in the IntelliSense window, the body of the code, and a short description. So let's create a snippet that will insert products into the table that we just made in the Kinetico database. This will be formatted as JSON, which uses name and value pairs, so it might look a little bit strange at first if you're not used to writing JSON. Everything is going to get wrapped in double quotation marks, and we'll use colons to separate names from their values. Okay, let's come down to line number 14, and I'll press Enter to move that closing curly bracket down one more line. First, we're going to create a new object. I'll name this snippet Insert Product, So in double quotation marks, type in insert product. After that, type in a colon and open up a new set of curly brackets. We'll move the closing bracket down a line. Now we need to fill in the prefix, body, and description components. The prefix is the IntelliSense trigger that will activate the snippet. Type in double quotation marks prefix, then a colon, and then in another set of double quotation marks, SQL insert product, all one word. We'll close the double quotes, type in a comma, and come down to the next line. Next up, we have the body. We'll go ahead and type that in, type in the double quotes, and press colon. This one is going to have a multi-line value, so we'll put it in square brackets. I'll open up a bracket and press enter to move the closing bracket down a line. Let me actually scroll down on my screen a little bit to bring everything up higher so we can see it easier. Inside of the body is the SQL code that the snippet will activate. The first line of our snippet's body is going to be a comment. I want the comment to be a human-readable sentence that describes what product is getting inserted into the table. I'll open a double quote and start the comment with 2 hyphens, and then we'll put in the text, adds, and we'll make reference to 2 placeholder variables. We do it like this: single quote, $, and an open curly bracket, the number 1 and a colon, and product name. I'll close the curly bracket and close the single quote. So this sets up our first variable, and it's called product name. Then I'll put in the text costing, and we'll make a second variable. The second variable will be named price. And we'll finish off the text of the sentence for the comment. It'll read to the Kinetico dbo.products table. We'll finish it off with a closing double quotation mark and a comma at the very end of the line. These 2 placeholder variables will get filled in with text to make a legible sentence that describes what our snippet is going to be doing. All right, let's press enter and come down to the next line of the body. Then we'll type in double quotation marks and we'll fill in the SQL code that we want to execute. The first line will be insert into dbo.products. I'll type a comma and come down to line number 20. The next line of the SQL code is our values clause. And the values that we're going to insert are going to be the placeholder variables that we've previously established. So in single quotation marks, $1, comma, and $2. We'll finish the values clause with the closing parenthesis and a semicolon. Then we have the double quotation mark to end the line, followed by another comma. Then on line number 21, in double quotes, the word go. This will tell SQL Server to execute that command all by itself. So that finishes our body. Let's go ahead and close the square bracket, and I'll type in a comma. Now we just noticed that this bottom square bracket just turned red, and that indicates an error. And actually, now that I'm looking at it, I see that I'm actually scrolled over a couple of lines. So when I scroll back here to the left, I can see the additional curly braces that finished up my statement. So I was actually scrolled over just a little bit too far to the right, and that extra bracket was already there. So let me get rid of that, and I'll bring that back up, and we'll finish the body like that. Finally, we need to add in the description to our snippet. Just like the prefix and body, this gets written in double quotes, and the value for this will be add a product to the Kinetico DB. And that finishes our insert product snippet. I'll save all of this code into the exercise files as snippet complete so you can reference it if you need to. But at this point, I'll press Ctrl or Command S on my keyboard to save the JSON file, and we can close the tab. Now let's test it out. I'll right-click on the Kinetico database and open up a new query. Then I'll type SQL to open up the IntelliSense window that shows me all of my snippets. Then we can either scroll through the list or just continue typing SQL insert product. Eventually, it'll show up in the IntelliSense window. You can see our new snippet is listed right there, and I'll press enter. That adds in the SQL code that we've just typed in, and it highlights the first variable for product name. I'll fill in the value solar charger. Notice that both instances get updated at the same time. Then I'll press Tab to move over to the price variable, and we'll put in the price of $59.95. Press Tab again, and that finishes our Insert Into statement. Press the Run button, and the command is executed, and a single row is inserted into the table. We can close this tab now, and not save any changes to that script. And I'll go over to the Products table, and right-click, select Top 1000, and there is the one row that we've just entered with the help of our snippet. And that's just a start for our custom snippet. If you want to go back and refine the snippet, maybe you want to do a check and make sure that we're working in the right database first before trying to add a record to the table, then you can always go back to the custom snippet editor by pressing Ctrl or Command-Shift-P on your keyboard to open up the command palette, typing in snip, and then press Enter and Enter again to edit that SQL.json file, and it brings you right back in. Then you can continue making any adjustments that you want to the snippet and save it back out again. Support for interactive notebooks is an exciting feature of Azure Data Studio, but rather than just tell you what they are, let's just jump right into one so we can see it in action. I'm going to go up to the File menu and choose Open File, and then I'll browse into the Exercise Files, Chapter 4, where I have a notebook file called twotreesnotebook.ipnyb. Now you may think that this is an odd choice for a file extension, but notebook documents have their roots in the world of Python programming. And now that you know that, the file extension may make a little bit more sense. It stands for Interactive Python Notebook. The format was originally created for an application called Jupyter to support building workflows in data science, scientific computing, computational journalism, and machine learning. Microsoft has extended the format to support SQL code execution and brought it into Azure Data Studio. So let's select this file and press Open, and we'll see what it looks like. When the notebook loads, you'll see a rich document that includes formatted text and executable code. At the top, we have a logo image, and then we have heading text at different sizes. Descriptive text can be highlighted, bolded, italicized, and you can even include hyperlinks, like this one right here that'll jump right out to the Two Trees Olive Oil Company's website. All right, let's close the web browser, and we'll go back into Azure Data Studio and the notebook. Below these text blocks, we have a dividing line that breaks up the document into sections, and then we have an interactive block of SQL code. This particular notebook has been set up to allow users to run some routine analysis queries on the database. And the first query will pull information about the 3 most recent orders. Before we can execute the query, though, we need to connect this notebook to the correct database server. At the top, in the Attach To drop-down menu, change it to Change Connection. That'll open up your Connections panel, and in the Recent list, select the SQL Server connection and press Connect. Now that our notebook is attached, we can run these queries. Press the Play button on the left-hand side of the first query, and it'll execute. And after a moment, it'll reveal a data table that shows me the 3 most recent orders from the database. Incidentally, if you just go over here and press the Play button without first linking the server connection like we did up here at the top, it would simply prompt you for that connection at that point in time. Okay, so this is the first query. Let's continue scrolling down through the notebook. Next up, we have a query that will reveal the order history from specific companies. There's a formatted note here that tells us how to manipulate the query to get different results. This SQL code uses a variable to store the current company of interest. It then uses that variable down in the where clause down here at the bottom to return the results for that specific company. When I press the Play button, it'll return the results, and I can scroll down to find all of the orders for Blue Vine. Then if I scroll back up here into the code block and change the line number 1 from Blue Vine to Flavorville, that'll update the variable named company. I'll press the Play button again. Then once again, I'll scroll back down to see the results, and they've updated to show me all of the orders from Flavorville. The interactive nature of this code block makes it very convenient to rework the queries for different scenarios. Finally, let's scroll down a little bit more to the very bottom. We have the third code block here. This one will analyze our data and find the products with the most sales. This query uses a window function to count up the sales for each product and then sorts the results. Press play to execute this query, and once again we can scroll down to see all of the data. It quickly and easily shows me that the first cold press oil in the 8-ounce size is our most popular product with 9 units sold. Now at the top of each of these results grids are the same export options that we've seen previously. You can output your results to a CSV file, an Excel file, a JSON file, or an XML file. You can even switch over to the chart view, which may or may not be helpful depending on the query that you're looking at. This one, in fact, is kind of a mess, so probably not that useful. Let's use that button again to switch back to the results grid. Okay, let's now scroll all the way back up to the very top of the notebook file. In the upper right-hand corner are some buttons. The eraser icon will clear out all of the results and reset the notebook. You can also collapse the code blocks with the first button, and this will make it so that each of these code blocks only shows the first line of the query and makes things a lot more compact. And if you want to run every code block all at once, you can do that with the button on the left called Run All. This will go through all of my code blocks and execute each one. And now as I scroll through, I'll see here's the results from the first code, here are the results for the second block, and here are the results for the third one. All right, let's go all the way back up to the top again and clear everything out. Finally, let's take a look at this kernel drop-down box. It's currently set to SQL, which is what allows us to execute SQL queries. But notebooks are also used for different programming languages, and you can execute those here as well in Azure Data Studio, as long as you have the appropriate development environment installed on your system. Currently, there's options for PySpark, Scala, R, Python 3, and PowerShell. However, if you try and switch the kernel, for instance, if I switch over here to Python 3, it's going to prompt me to configure and install the Python runtime. If you have the required resources and knowledge, you can build interactive scripts in those languages to work with your databases as well. I'm just going to press the cancel button and not install Python. The Python and R languages in particular are very well suited to performing complex data analyses, and would make notebook support in Azure Data Studio even more powerful. So that's a quick tour of what a notebook is. They combine formatted text and interactive code blocks to help you streamline your data analysis projects. Notebook files are constructed from 2 basic building blocks. Let's take a look at how this works by going up to the File menu and choosing New Notebook. The keyboard shortcut on Windows for this is Alt-Windows-N, and on macOS it's Control-Option-N. A new notebook file will open up here, and we will have the option to click on plus code or plus text to add in our 2 elements, either code cells or text cells. You can also come up here into the menu where we have a cell drop-down menu, and we have those 2 options there as well, code cells and text cells. Text cells are for any documentation that you want to add into the notebook, and you can type whatever you'd like into them. Let's go ahead and click that option to add a text cell into the document, and I'll just type in the text, "This is a text cell." There are basic formatting options above to bold, italicize, underline, and highlight your text, and we can go through and just highlight a couple of words and then easily apply some of these formatting options. Next up, there's an option to insert a formatted code block, but this will just be a static, non-interactive piece of code that you want as part of the documentation. It's different from the executable SQL scripts that we'll add in just a moment with an actual code cell. Next to that, we have the hyperlink tool for adding links to external websites. There are options to format lists as either bulleted lists or numbered lists. And then finally, we have the paragraph menu for choosing header styles. All of this formatting is using a syntax styling system called Markdown behind the scenes. On the right are 3 options. The first is to view the styled text, which is what we're taking a look at right now. The right option is to view the Markdown syntax. When I switch to this view, you'll see that the text changes to include all of the symbols that indicate the type of styling that's being applied to it. Markdown uses standard keyboard symbols to define these styling parameters. For instance, placing 2 asterisks on either side of a piece of text is the way that you make it bold. Underscores on either side of a piece of text is how you denote italicized fonts. Back on the right, we have a third option for our view, and that's called a split view. Let me go ahead and activate that. This will show you both the markdown version over here on the left, as well as the fully rendered text over on the right. I like this view a lot because it allows you to use the markdown syntax and immediately see the results. The benefit to writing in Markdown is that it's a standardized system that's popular in web design, and it's very fast to type out once you get used to the symbol conventions. To see how this works, let's go ahead and go up to the top and choose to add in a new text cell. Then I'll switch my view over into the split view so we can see both the markdown on the left as well as the rendered text on the right. And then I could just start typing. As I'm typing, I can immediately apply the formatting at the same time without ever having to leave the keyboard. Adding an appropriate formatting and differentiating between different sized headings and subheadings can make your notebook files much more legible and easy to navigate. Then we'll just switch over to the fully rendered view, and there is my final document there. We can see we have a heading font, a subheading font, and we have bold and italic text inside of a paragraph. The Markdown formatting syntax has a rich set of options, and there's a lot of different ways that you can incorporate them into your notebooks. I like the quick reference guide that you can find at markdownguide.org/cheat sheet. Here you'll find a list of basic syntax elements, as well as some extended syntax that you can use in your Azure Data Studio notebooks. Now, unfortunately, Azure Data Studio doesn't support every one of these styling elements, but many of them, like formatting tables or fenced code blocks, will work just fine. And they can bring a new level of polish to the design of your notebook files. The second building block that makes up a notebook file is called a code cell. Let's start a new notebook file and we can take a look at it. In the top menu, in the cell dropdown, go ahead and choose Code Cell. Here we can start writing the SQL code that you want to execute. The language that the cell will use is noted in the bottom right-hand corner and is dictated by the kernel setting of the notebook. Notebooks can only be set to execute a single language, so if you wanted to run some SQL code on your server and then some Python routines, you'll actually need to create 2 separate notebooks to do that. Okay, in our code cell, let's type in some text. This code cell now has 2 select queries. The first will return information about the server's version and operating system, and the second will return data from one of the tables in the TwoTrees database. Notice that I'm using a fully qualified reference to that table, which includes the database name TwoTrees, the schema inventory, as well as the table itself, categories. Notebooks execute against the server by default, not at the database level, so it's important to be specific about which database you're looking at in these queries. You can click off to deselect the cell, and there's the finished code cell. Now we need to connect the notebook to the SQL Server instance. I'll do that by coming up to the Attach To menu item, and then clicking Change Connection. I'll choose my SQL Server instance and press Connect, and now my notebook is ready to execute. You can run the code by pressing the play button that appears on the left when you hover over the cell. Both queries execute, and the results are shown below. So here is the result of the select at version query. We can see that we're running SQL Server version 2019. And then below that, I have the results from the select statement of the inventory.categories table. To reset the code cell, you'll come up here to the top, and in the toolbar for the cell, click on the ellipsis button. At the very bottom, we have the option to clear results. That'll clear out the tables and reset those queries. Another useful option in the toolbar is to split the cell. This will use your cursor position to divide a code cell into 2 parts. Place the cursor at the very beginning of line number 2, and then click the Split button here on the toolbar. We've now divided the code into two separate code cells that can be executed independently. Now we can continue refining the SQL code. Another way of ensuring that queries are executing in the correct database is to start with a use command. For instance, I'll change this second query to use two trees. Then I'll issue a go command, followed by the select statement. At this point, I can remove the two trees qualification from that query. In fact, we can take this a step further and query two different databases at the same time. Let me come down here to the end, and I'll add in another use statement and connect it to the Kinetico database. Once again, we'll follow that with the command go, and we'll select some information from that database. Now when I click the play button over here on the left, it'll execute the commands against each database, and I can scroll down and I can see the information from the two trees database here, as well as a table from the Kinetico database down below. Okay, now let's talk about saving your notebook. Just like any other document, you can save your work from the File menu. Then come down and either choose Save, Save As, or Save All. This will write out the notebook to disk, and you can share it with colleagues or file it away for later use. Now there's one very important consideration that you need to make though. If you have results showing in the notebook when you save the file, these results will be saved in the notebook file as plain text. This makes it easy to share the notebook with another user, and they can immediately see the results that you're getting when they open the file. They will also have the ability to clear your results and execute the same code cells on their own. If you clear the results first, though, either by coming up here into the ellipsis button for the cell and choosing Clear Result, or by coming up here to the top toolbar and clicking the eraser icon to clear the results from all the cells, then if you save the file with that state, the notebook will only store the executable code and none of the data. This may be preferable if you have any privacy or security concerns about the data that you're querying. So keep that in mind, that notebooks may store results in your database depending on the state that your code blocks are in when you save. And that's the code cell in Azure Data Studio Notebooks. You can use them to create workflows for common data analysis queries that you want to execute regularly, or build a diagnostic notebook with all of the queries that you use to monitor the health of your databases. There's one more component that you can add to a notebook file, and that's to incorporate images. These can either be graphical flourishes, like a company logo, or more functional elements, such as diagrams or flowcharts that help illustrate a concept. Let me start up a new notebook file here, and we'll take a look. Images are added in two text cells, so I'll go ahead and add in a new text cell to my document. Now you're not going to see the option when viewing just the formatted text. We need to switch into either the markdown or the split views over here on the far right. I'll go ahead and switch into split view. When you do that, you'll see a new icon appear here on the toolbar to insert an image. Clicking that will prompt us to either select an image from our computer, or we can provide a URL to an online image. I'll choose the option to grab an image from my computer, and then click the folder icon on the far right to browse my system. Inside of the exercise files chapter 4 folder, we have the two trees logo graphic, and I'll go ahead and grab that and press open, and it'll put in that file path. Next, we have a check mark here to attach the image to the notebook. If you choose this option, the image will be copied into your notebook file so that it'll be more portable, and you won't have to worry about the graphics not showing up for other users. If you leave that option unchecked, it'll reference the location on your hard drive, and if the file is moved or not available, it won't show up in the notebook. I like the option of being more portable, so I'll choose to attach the image. Keep in mind though that this will increase the size of the notebook file. So with these options filled in, I'll press the Insert button, and there is my two trees olive oil graphic right there. Once the image is inserted, we can continue on adding text with the markdown syntax. I'll just add in a new title here. Then I'll click off of it, and we'll view the final result. So there's a text cell with an attached image. They can add additional polish to your notebooks and make them more engaging or instructive. Keep in mind that images are placed at 100% size, and there isn't a way to scale them here in Azure Data Studio. So you may need to do that in an external graphics editor first, before attaching them to your notebook files. And if you want to continue working on your text cell, just click it once to activate it, and either click the pencil icon here to open it up in edit mode, or simply double click on the text cell, and it'll jump you right back in here and give you access to that toolbar again. One of the most powerful features of Azure Data Studio comes from its Community Extension Marketplace. These allow you to bring in new functionality to the program and customize its capabilities to meet your needs. We've already added a couple to our installation, but I wanted to point out a couple of other features. Remember that you can get to the Extensions Marketplace by clicking on the building block icon over in the activity bar. At the top, you'll see your installed extensions. You can click any of them to read their information, and there are options here at the top to disable or completely uninstall an extension if you no longer want it. Back in the sidebar at the bottom is a list of the available extensions. Some of them come directly from Microsoft, but the vast majority are contributed by other Azure Data Studio users just like yourself. You can scroll through the list to see the wealth of options, or you can come up to the top and do a search to see if there's something that matches your requirements. So let's install another extension. I'm going to search for New Database. This reveals a new extension. I'll go ahead and click it, and we can see its details over here. This extension will add the ability to create new SQL Server databases by right-clicking the Databases folder in our server connection and choosing the option from a pop-up menu. This functionality is standard in SQL Server Management Studio, and that's what many people are used to. But the ability is missing here in Azure Data Studio. But with this extension, we can easily add it in. Now, some extensions will install right from within Azure Data Studio. Others will have you download an external installation file. This one takes the latter route. So pressing the install button will actually open up your web browser and go to the contributor's GitHub page. This is where we can scroll down and find the Visix installation file. It's this one right here. I'll go ahead and click it to put it in my Downloads folder. Incidentally, this is the same file extension package used by Visual Studio Extensions, which is where the acronym comes from. Now that the file is downloaded, I'll close my web browser and we'll go back into Azure Data Studio. Then in the extension sidebar on the left, I'll click the ellipsis button up here at the top, and I'll choose the option to install from Visix. Then I'll go into my Downloads folder, we'll find the Visix file that we just downloaded, and press Install. Azure Data Studio warns me that this is a third-party extension and might involve security risks. I think this one's pretty safe, so I'll go ahead and press Yes, and it'll install the extension. Now I can clear the search results by clicking on this button in the sidebar, and it'll return me back to my full list. Now I can click on that extension, and I can see that it's installed. All right, let's go ahead and test it out. I'll switch over to my Connections sidebar, and then inside of my SQL Server instance, I'll right-click on the Database folder. And here we have a brand new menu item to install a new database. It even comes with its own keyboard shortcut. Control-Shift-D all at once, and then the B key. This is the same shortcut that's used on Windows and Mac OS. I'll go ahead and click that menu item. That brings up this menu up here at the very top, and I'll name my database. I'll just call it My New Database and press Enter. After a moment, I get the message that the database was created, and I can go over here to my Databases folder, right-click and choose Refresh, and there it is right there. So as you can see, the Extension Marketplace can add a lot of functionality to Azure Data Studio so that you can tailor the application to your unique requirements and working preferences. Another extension that I find to be really helpful is called the Query History extension. It'll add in a new item into the panel that appears at the very bottom of the screen. Right now my panel has Problems, Output, Terminal, and Tasks. If you're not seeing the panel down here, you can activate it by going up to the View menu, pointing to Appearance, and you'll toggle the panel on here. or you could use the keyboard shortcut Control or Command J. With the panel on now, we can go over to the extension marketplace, and I'll do a search for the extension Query History. That'll bring it up here in the search results. You can see it's published by Microsoft, and it adds a Query History panel for viewing and running past executed queries. This makes it easy to see the status of your queries, whether they were successful or if they failed, and you can rerun them right from the panel. Let's go ahead and press the Install button, and as soon as you do that, you'll notice that we have a brand new item down here in the panel called Query History. Now at first, there aren't going to be any queries to display, so we need to start running some on our server in order to see how this works. I'll close the extension tab and we'll switch back over to our connections. Then I'll right-click on the Kinetico database and choose New Query to open up a new editor tab. Then I'll just type out a couple of queries. First, we'll select the database version. I'll press the Run button and we'll see the results here, as well as a new entry in the query history. The green checkmark tells me that this query executed successfully. I can see the exact time and date that I executed the query as well. Let's run another query. This time we'll select some data out of a table. We'll try pulling everything from a table called dbo.departments. I'll press the Run button, and this time the query fails because there is no table called departments with an S. In the query history, I get a line here that indicates that the query failed, and I can still see its date and time that I tried to execute it. I'll fix the query. Let's change the name of the table back to department, singular, and rerun it. And this time I get another entry in the query history panel, and I can see that this one was successful. If you right-click on any of these queries, you get a contextual menu with some helpful options. You can open that query in a new editor tab. This will allow you to edit the query and execute it again. You can also right-click on any of these entries in the query history panel and choose Run Query. This will open it up in a brand new tab and immediately execute it again. Finally, you can right-click on any of these entries and choose Delete if you want to remove it from the history, or you can right-click and clear all of the history, or simply pause the capture for a little while. So this is the Query History extension. It's a useful addition to Azure Data Studio that can help you be more productive by maintaining a list of previously executed queries, and it allows you to quickly see their status and rerun past queries without having to type them out again. If you have a bunch of tabular data that you'd like to import into SQL Server, then you can streamline the operation by installing another extension. Head over to the extension sidebar, and this time we'll do a search for an extension called SQL Server Import. This extension will read CSV and text files and intelligently create a new database table and assign appropriate data types to each column. Let's go ahead and press the Install button to add it to our Azure Data Studio instance, and then I can close the tab. I'll switch over to the Connections sidebar, and we can test it out. I would like to use the extension to add in a new table to the Kinetico database. So I'll right-click on the database, and at the bottom, we have a new option for the Import Wizard. The first time you activate this wizard, it's going to take a moment to initialize the extension, but eventually it will open up the Import Flat File Wizard. Now we just need to go through and fill in the details. I want to create a new table into the Kinetico database. I'll choose that from the pop-up menu. Then we need to browse to the file. Inside of the exercise files, in the Chapter 5 folder, I have a list of products that I want to bring in. I'll go ahead and select that product CSV file and press Open. I'll leave it in the default schema for the database, DBO, and I'll give it the name Kinetico Products. Go ahead and press the Next button. The wizard will then read the first 50 rows of data and make some assumptions about the data types. Everything looks good on this screen. It's splitting everything out appropriately. I'll press the Next button. On this screen, we can adjust the assigned data types for each column and select additional column parameters. I'll make a few changes here. For the product ID, it's assigned the data type of an nvarchar50. Now I know for the data that I don't need that many characters, so I'm going to change this to an nvarchar20 instead. I also want this column to be the primary key for the table, so I'll place a check mark there. For the manufacturing cost, it assigned the data type float, but I know that this data is better represented as a small money data type, so I'll choose that from the list. With those changes made, we're ready to go down and press the Import Data button. The wizard will go through, create the table, and import all of the data. When you're done, press the Done button, and you're all set. Now we can go into the Kinetico database. I'll expand the Tables folder, and there is our new table. You may need to right-click on it and choose Refresh in order to see it. If I right-click on the table and choose Select Top 1000, we'll see all of the data that we just imported. So the SQL Server import extension is another example of a useful capability that can be added to the base installation of Azure Data Studio. Keep in mind that it won't work with Excel files, so you may need to export your data into a plain text or CSV format first before bringing it into your databases. The Azure Data Studio interface can be localized into different languages. If you guessed that this is accomplished through the Extensions Marketplace, then you'd be correct. In the Extensions sidebar, do a search for Language Pack. This will show you all of the available options. At the time of recording, there's extensions for Simplified and Traditional Chinese, French, German, Italian, Japanese, Korean, Brazilian Portuguese, Russian, and Spanish. I'm going to install the language pack for the German language. I'll click on it there and then press the Install button. Once it's installed, you'll see a notification that asks you if you'd like to switch. Press the Change Language and Restart button, and Azure Data Studio will quickly restart. And when it comes back up, you'll notice that the welcome screen, all of the menus, and the majority of the interface is now in German. To change the language back, you'll need to go to the Command palette. Press Ctrl-Shift-P, or Command-Shift-P if you're on a Mac, to reveal the command palette. Then type Display Language, and that'll take you to the configuration options. Press Enter to move into it, and then you can use your arrow keys to select your preferred language. I'll press the arrow key down once and select EN for English. Then I'm prompted to restart Azure Data Studio again. Press the option to restart. And when it comes back, we're right back to where we started in English. So if you feel more comfortable working in your native tongue, you can switch up the interface with the appropriate language pack extension. If you need to monitor the health of your database server, then it should come as no surprise that there's an extension that can help you out with that. I'm going to go back to the marketplace, and this time we'll search for Server Reports. The Server Reports extension is another extension published by Microsoft, and this one creates a dashboard which displays important performance metrics about your server. You can use it to quickly see the size of data and log files, CPU utilization, weight statistics, and more. Let's go ahead and install this one, and we'll take a look at it. Once it's done installing, I'll close the tab, and we'll switch back to the Connection sidebar. Then I'll go over to the SQL Server instance and either right-click on it and choose Manage, or you can simply double-click on it to open up the dashboard. There are two new options at the bottom here that we haven't seen previously that were just added by the extension. Underneath Monitoring, click Server Reports. This page includes a couple of charts that show you the database size for both the data and log files for all the databases on the server. Below that, we have a chart for CPU utilization over the last half hour. And if we scroll over to the right, we'll see that we have some additional charts for the backup growth trend. And this one up here is for the top 10 database buffer usage. All right, let me scroll back to the upper left-hand corner. Now, each of these charts has an ellipsis button in the upper right-hand corner. This will reveal two options. You can either refresh the chart's contents, or you can run a query. I'll go ahead and choose the Run a Query option. That brings up this long query here, and it'll display the results. This displays the same information, but in a tabular format, which might be useful for your reporting needs. When you're done reviewing this data, you can close the tab, and that'll take you back to the dashboard. Also in the Server Reports page, there's a tab for Performance. This will show you wait statistics for different processes, and monitoring these can be useful for query optimization and performance tuning the system. Back on the left, we have another section for TempDB. This will typically display information about metadata and allocation contention. You can scroll across to see some different charts here. Let me scroll up to the top. There's the metadata contention, and over here we have overall contention and allocation contention. These would be useful for troubleshooting slowdowns and can indicate whether you need to add additional data pages to TempDB. Now, my example database isn't really being used by anybody else, so there's nothing to show here. But in an active database, this could be a good source of performance information. And so that's the Server Report extension. It's designed to mimic the reports that SQL Server Management Studio users may be used to getting. And it brings another feature over from that program and makes it available here in Azure Data Studio. There is one more monitoring extension that I'd like to share with you. In the marketplace, do a search for Who is Active, all one word. The Who is Active extension adds a number of features that make it easy to monitor the impact each connection is having on the server. With it, you can see the memory and CPU usage rates and individual session properties. I'll install it so we can see it in action. Once it's installed, I'll close the tab and we'll return back to the server sidebar. Then I'll double-click on the SQL Server instance, and that'll open up its dashboard. Now, at the very bottom, we have a new tab for SP Who is Active. The first time you go here, though, you're not going to get any results. This particular extension requires a new stored procedure to be added to your server first. I'm going to minimize the connection sidebar just by clicking on its icon one more time. That'll give me more room for the dashboard. Then you should see a button appear at the very top that says Install SP Who is Active. Clicking that will take you out to a web page. Now, this project has recently moved over to GitHub, so we'll have to follow another link from here. It's this one here, right here next to the note. That'll take you to the GitHub page for the product, and then we can switch over to the Code tab. Finally, we'll find the actual SQL file that I need. It's called spwhoisactive.sql. Make sure you're choosing this one here, and not the one below it that says Who is Active as 3 separate words. This is an older version of the file that we don't need. So click on this one up here. That'll take you into the text of the file, and then over on the far right, click on this icon with the 2 squares to copy the raw contents. So this file consists of a very long bit of SQL code that we need to execute on our server. Once you have it copied, go ahead and close your web browser and go back into Azure Data Studio. Then I'll open up the server sidebar once again, right-click on the SQL Server instance and choose New Query. Then I'll paste in the contents of that file. You can see it pastes in 5,495 lines. Press the Run button, and it'll add all of the stored procedures that it needs onto your system. When that's done, we can close that tab. I don't need to save any changes, and I'll also close the dashboard. Then I'll double-click on the server again to rerun the dashboard, and finally come back down to SP Who is Active. We should now see a couple of charts. These reveal the resource utilization of each active user on the server. You can use this dashboard to monitor user activity, which users are hitting the CPU the hardest, and which ones are placing the largest load on memory usage. With this information, you can work to better balance your resources, or identify queries or other procedures that are placing heavy loads on your system. So the Who is Active extension places another set of useful monitoring charts into the main server dashboard for your SQL Server instances. For those of you that need to monitor server health, having more ways to get visual insights into the current status of the system can help you address issues in a timely fashion. You can quickly and easily change the look and feel of the Azure Data Studio interface by applying different color themes to the program. Click the gear in the bottom of the activity bar, and then choose Color Theme. The default is this light Azure Data Studio option at the top, but you can see that we have several different themes to choose from. We have light themes, dark themes, and if I scroll down this list here, we'll see we also have a high contrast theme. I'll switch to the dark Azure Data Studio theme, and you'll see the interface takes on a drastically different look. If you're working in a dark server room or office, this theme could significantly reduce your eye strain. These color themes will also apply new code highlighting when writing queries. Let's right-click on one of our tables in a database, and I'll choose Script as Create, and you can see the color highlighting as it's applied to our new text. Let's go back down to that gear icon and take a look at another color theme. This time I'll choose Monokai Dimmed. This takes a softer take on the same basic color palette. Then if we take a look at another one called Solarized Dark, you'll see that it brings in some blue tones. Now additional themes can also be added by visiting the extensions marketplace. Do a search for theme, and you'll see that we have a number of themes that have been contributed by other Azure Data Studio users. I like this one called Pastelin. Let me scroll down on the page here. We can see a preview of it. It's a soft, dark theme with vibrant color code highlighting. So whether you prefer a light or a dark interface, or simply want to change things up, head over to the themes and pick a new favorite. After working with Azure Data Studio for a while, you might decide to alter the default configuration of the program to better suit your workflow. There's a huge array of options available in the application settings. To get there, go down to the gear icon and then choose Settings. On the left, you'll have different categories of settings that you can use to navigate, or you can just start scrolling through this list. And scrolling, and scrolling, and continue scrolling, and you can see that there are a ton of options. I'm actually only about halfway through. At the top, we have a search bar, which helps you locate things that you want to change. Go ahead and type in font. This will reveal the 33 settings that match the keyword, and I can scroll through just the font settings. Let me go ahead and scroll the results up to the very top. You can then clear your search by clicking this X button over on the right, and that'll reset everything and show you all of the settings again. Now, any setting that you change from the default will get highlighted, so you can quickly see what modifications you've made. On my system, I've adjusted the font size here up to 18 points. Since this is not the default value, it shows this blue bar on the left. To reset the font size back to the default setting, go ahead and click the setting, then click the gear icon in the upper left-hand corner, and you have the option to reset it back to the default value. I'll go ahead and just click off of this to keep my change at 18 point. So that's the procedure. You can search through the settings, find anything you want to change, and simply change its value. Or click the gear icon to reset it back to default. Now it's just a matter of browsing this extensive list of settings to find things that you may like to change. For instance, when you create a server group by pressing the icon over here in the server connection sidebar, you have your choice of these color chips. These specific colors are defined in these settings, which means we can easily put in our own colors if we prefer a different set. Go ahead and press cancel. Then in the settings, we'll search for server group color. There's a link here to edit the colors in the settings.json file. When you click that, it opens up that file, and here are all of those color codes starting on line 94. These are hexadecimal color codes that are used in web development, and you can find attractive color palettes online that you can simply copy in. When you're done, you'll save that file and then close the settings.json file, and that'll apply the settings to your new color themes here when you're creating a new server group. I'm not going to save any changes here, and I'll just close the file without making changes. Next, we can shade the editor tabs that appear across the top of the screen to match the colors that we've used for our server groups. This can clarify what editors go with which server. Search the settings for tab color. In the setting, we have 3 different options. Off is the default, which won't color our tabs, Border will apply a single color border, and Fill will shade the entire tab. I'll go ahead and press the Fill option. Then in the connection sidebar, I'll right-click on a table and choose Script as Create. That'll open up the query in a new tab, and you'll notice that the tab automatically gets the same color as the group that the server is in. This makes it easy to identify which tabs go with which connections. All right, let's close that tab. We'll go back to the settings. I'll then change my tab color mode back to the default of off. Finally, let's search for one more setting. I'll search for color theme. Here you can set your preferred color themes for both light and dark modes, and at the very bottom there's an option called Window Auto Detect Color Scheme. This will allow you to change the interface automatically to match the theme of your operating system. So those are a few settings that you can adjust to make Azure Data Studio even more enjoyable to use. There are a ton of other options though, and I encourage you to spend some time and peruse all of the available settings to find the ones that matter most to you. Microsoft has built Azure Data Studio to work extensively through the keyboard input. There are hundreds of shortcut key combinations that can be used to control the program, and some features can only be accessed through the keyboard. To see a master list of all of the shortcuts available, visit the gear icon in the bottom of the activity bar and then choose Keyboard Shortcuts. You can scroll through this list to see everything that's available, but just like the settings, we have a search bar here at the very top that'll help us get to specific key bindings. Type Workspace, and that'll reveal all of the workspace-related keyboard shortcuts. For instance, the one to close a workspace is Control-K and then F. Now this is kind of an unusual keyboard shortcut in that it requires two different components. There are so many shortcuts here that they've had to be split out into something called a shortcut chord. When you press Control or Command-K, that starts the chord. When I do that, take a look down at the status bar at the bottom of the screen. You can see that Azure Data Studio is waiting for the second key of the chord. So for instance, you can press Control-K and then Control-T, and that's the shortcut to open up the panel for the color themes. So that's how those multi-part shortcuts work. They require two separate components. I'll press the Escape key to get rid of this menu. Now you're obviously not going to be able to remember all of these shortcuts, or even most of them. But after working in Azure Data Studio for a while, you'll identify actions that you perform regularly, and there's almost always going to be a shortcut that'll help you out with whatever work it is that you need to do. You can even modify the default shortcuts to make things more memorable if you'd like. When you hover over a shortcut in the list, you'll see this pencil icon. Clicking it will allow you to type in your own custom keyboard combination. Or you can right-click on any of these options, and you'll have additional things that you can change. You can either change the key binding, add a key binding, remove a key binding, or reset it back to its default. And you can even change the when expression. This will make the shortcut only apply in certain scenarios, and you can see them listed over here in this column of the Shortcuts menu. There is a rich set of customization options here, and spending some time reviewing this list will make you more efficient in Azure Data Studio. We just saw that there are a lot of keyboard shortcuts available, but if you can only remember one, it should be Control-Shift-P on a Windows or a Linux computer, or Command-Shift-P on a Mac. This brings up the command palette, and from here, you can get to every single one of Azure Data Studio's features right from the keyboard. Let's say you want to start a new query. Just type in New Query and press Enter. It opens up a new tab, and you can get straight to work. In fact, you can press Command-Shift-P or Control-Shift-P, NEWQ, and it'll get you right there. You don't even have to type in the whole word, or even the space. The command palette does some fuzzy text searching, so you can type words that appear in the middle of a command, and it'll still do a good job of figuring out what you're after. Let's say you want to change your color theme. You can press Control or Command-Shift-P to open up the command palette, CTHE, and it'll jump you right to the preferences for your color theme. Press the arrow down key, press enter, and you're right in. I'll press the escape key to dismiss the command palette. Now I like to make a little game out of the command palette and find the fewest number of letters that I need to type in order to get to the desired command. For instance, if you want to disable all extensions, you can press Ctrl or Command-Shift-P, DIEX, and you're right there to the menu option to disable all installed extensions. So by typing one keyboard shortcut and 4 letters, I can get there. I think you can see how fast this can be, and why the command palette really is the only shortcut that you need to remember. With the command palette, you can zip around Azure Data Studio as fast as you can type. Zen Mode is one of those productivity enhancements that came to Azure Data Studio through the development of Visual Studio Code. It's primarily intended to help you focus on writing code or queries. Let's open up a query by right-clicking on one of the tables in our databases and choosing Script as Create. Now let's say that we wanted to really focus in on this query and remove all other distractions from your field of view. You can enable Zen Mode by going up to the View menu, coming down to Appearance, and then toggling on Zen Mode right there. There's also a keyboard shortcut. On a PC, it's Control-K and then Z, and on a Mac, it's Command-K and Z. Or, my preferred way is with the command palette. So let me click off of this. You can press Ctrl or Command-Shift-P, then type Zen, and press Enter, and that'll toggle on Zen Mode. In Zen Mode, the current editor tab that you're working with is enlarged to fill your monitor, and blank areas are added to the left and right to block out any distractions. Now you can focus all of your attention on the task at hand. If you want to adjust the width of the view, you can drag on the left or the right edges to make things wider or narrower. From here, you still have full access to the command palette to run any commands that you want. I'll go ahead and press the escape key to get rid of that. And when it's time to leave Zen Mode, just tap the escape key on your keyboard twice. That'll return the interface back to normal. So during those really intense query writing sessions, consider enabling Zen Mode to help you focus. Many of the tasks that database developers need to accomplish happen on the command line. Azure Data Studio includes an integrated terminal so that these tasks can be performed right inside of the program without having to switch to a different application. To start up the terminal, you can find it in the View menu and come down. There's an option for Terminal here, or you can use the Control' shortcut. The terminal appears in the panel at the bottom of the screen, along with the Problems panel, as well as the Query History panel that we enabled earlier through an extension. Now, the terminal that runs will be slightly different depending on the operating system that you're using. On macOS, it's going to default to Z shell. On Linux, it'll use the Bash shell, and on Windows, it'll default to PowerShell. The exact shell that loads can be altered in the user settings file if you prefer a different shell than the default one. With the shell open, though, you can run all of your favorite command line operations. This includes local file system commands, such as ls on Mac and Linux to list the contents of the current location, or dir in Windows will give you the same list of contents. You can run Docker commands, such as docker images. This will show you all of the image files that have been downloaded. You can also run SQL Server command line tool SQL CMD, if you have it installed, or even log into remote networks to administer other servers over SSH. On the right, we have several different icons for working with the terminal. Press the plus icon will add a second terminal window, and you can switch back and forth between them. You can even rename the terminal through the command palette. Press Ctrl or Command-Shift-P to open up the command palette. Type Terminal Rename, and press Enter. It'll then prompt you for a name. I'll call this terminal my Docker terminal. When you press Enter, it renames it over here on the menu on the right-hand side. This will make it easier to keep track of what's running in which terminal. You can open up multiple terminal windows by using this button here that'll split everything into multiple screens so you can have things side by side. You can also kill a terminal by pressing the trash can icon that appears to the right. Finally, you can maximize the panel with this button here. That way you can focus all of your attention on your command line activities. So the next time you're configuring a server or otherwise need to run an external script, instead of opening up another program, open up the integrated terminal in Azure Data Studio and perform the task right here instead. I've found that people that like working in a terminal environment tend to have very strong opinions on how that environment should be configured. The user settings has a number of terminal-specific options that can be customized in order to dial in your preferred setup. Once again, I'm going to return to the user settings, but instead of going down to the gear icon, like we've seen several times throughout the course, I'll use the command palette instead. Press Ctrl or Command-Shift-P to open up the command palette, then type user set. That'll jump you right to the preferences to open the user settings file, and press Enter to get right into the settings. Now I'm going to close the panel at the bottom of the screen to give myself some more room. I'll press the X over here on the bottom right. That way we can focus in on these settings. Then in the search box, I'll type in terminal, so we can focus on just the terminal settings. If I scroll up here to the top, we have some options that specify the exact terminal application that each one will run depending on the operating system. So here we have for Linux, OS X, as well as Windows. If I scroll down, we'll find some settings for the cursor. We can specify whether the cursor blinks or not, as well as the shape that it'll take. Further down, we'll find options for the font. We can specify the font family that'll be displayed in, as well as the size and its weight. So there are a lot of different settings here that control the style of the terminal. If you're a command line person, you'll want to dig in through these many settings to make sure that your copy of Azure Data Studio is dialed in to your specific preferences. I appreciate you joining me as we got to know Azure Data Studio. This program has already become one of my favorites, and I hope that you're as excited as I am about future development. If you'd like to keep up with what's new, you can follow the Azure Data Studio Twitter account, or make feature requests and file bug reports on Microsoft's GitHub repository. I really feel that Azure Data Studio is going to make it easy for everyday people to start leveraging the power of SQL databases in their work. If that's you and you're wondering where to go from here, take a look at my 5-course Database Foundations series, starting with the Intro to Databases course. This will give you a good working introduction on how relational databases work and how to build them in SQL Server, PostgreSQL, and Azure Data Studio. Once again, I'm Adam Wilbert. I'd like to thank you for watching, and I hope you have a great day.